thermal generation, because a beautiful little thing up there called merit order, which is an economic guideline in which the grid selects the generator that exhibits the least marginal cost of variable cost, which is the fuel cost. In this case, the fuel cost of renewables is zero. So then, in having dispatchable electricity in a given moment, renewables will be selected over other generation sources in the first place. But this is not enough because we still don't have the cost of the system that will be given by the bingo, the full cost of electricity, which is the sum of the levelized cost weighted by their generation fraction in the grid. Now, in this exercise, in the absence of renewables, we have only one generation source consisting of baseload, continuous, efficient generation, your car driving the highway, and another non-baseload or inefficient generation for peak and off-peak demand. But in the presence of renewables, things get a little bit messy because despite we have reduced the thermal generation, we must now add what you see in the dark gray bar there, a fraction of inefficient generation to back up these renewables that more or less behave like this. When we have enough sun and wind, they will be able to generate a full load capacity, apparently meaning that there will be no need of thermal backup. But this is absolutely wrong because behind that beautiful green bar there, we have a thermal generation source operating somewhere else in the grid at spinning reserve or rotating reserve or idle speed, whatever you want to name it, burning fuel without generating electricity, thus not earning money, sleeping, waiting there for the wind or the sun to go away. And when they do go away, they must wake up, quickly ramp up to fully replace the lack of renewable generation. So this is everywhere. And with this, we get to the first rule of thumb. If grid stability is demanded for every megawatt of renewable capacity, there must be at least 1 megawatt of thermal backup capacity for backup, sorry. And this is one of the biggest mistakes made by many nations in the West, starting by our country, Chile, Spain, and many others. Now let us see the difference between the levelized cost and the full cost of electricity. Within a certain range, the renewable levelized cost will remain constant because of the merit order we just saw, while the thermal generation levelized cost will go up mainly because of the increase in the fuel cost. But beyond a certain limit, the renewable levelized cost will skyrocket exponentially because it has passed a limit defined as a point above which there will start being an overflow of electricity. So the more we add installed capacity, the less it's able now to produce more generation than the one demanded in every moment. So that is a shape it follows beyond that limit, while the levelized thermal source will continue to increase almost linearly because there will still be renewable electricity dispatched to the grid, even though less and less each time. But seeing from the perspective of an integrated system, we can now, where the levelized costs are weighted by the generation fraction in the grid, we see that the renewable weighted cost will increase linearly and also exponentially beyond the limit, but now, surprise, the thermal levelized cost slightly drops. And why is this? Because we're assuming an efficient grid, more or less the one of the United States, in which only natural gas is used to back up renewables, the most efficient one for that purpose. In this case, the increase in the levelized thermal cost is not able to offset the effect of reducing the thermal generation, making its weighted cost to slightly drop. But this doesn't matter, because what matters at the end is the sum of both, which is the full cost of electricity. And this one, ladies and gentlemen, always increases, no matter what. Inevitably, we can improve its capacity factor. It will increase. We can reduce its investment cost, like it has happened over the last 15 years. It will continue to increase following that shape. And even worse, it increases from the beginning. from the moment there were no renewables in the grid. And even worse, it increases upwards, not downwards, as renewable advocates like to claim. To see if there will be, is or not, a limit for renewables, let's see which are the variables at play, where N is the installed capacity required to generate the fraction F of the demand D, where Z is the capacity factor of a given technology. Let's leave aside this for a moment, and we will use solar generation for simplicity reasons only to explain this, that more or less follows a sine curve. And we can see here that in the case of Norway, the installed capacity operating at full load capacity, that is at noon, at 12 a.m., when the sun is fully shining in a clear day, it will be able to generate at most 33% of the hourly demand shown in the horizontal line above. So we can continue increasing our renewable capacity because of the merit order and to reach the level of, for instance, the United States, 66%. So then, which is the condition to be at a limit? Easy, that the nameplate capacity matches the hourly demand. N equals V. It's easy to understand that beyond this limit, electricity in excess will be lost because we cannot inject more electricity into the grid than the one demanded in every single moment. Otherwise, we will be varying the electrical frequency, and I'm sorry, that cannot be done. Otherwise, we blow the grid. So if we replace N equals D in the left equation, we immediately get that the maximum renewable generation fraction in a grid is equal to its capacity factor. And beyond this limit, sadly, the case of my country, together with Germany, much worse, that the excess generation follows an exponential increase, while the dispatch electricity beyond this limit, a logarithmic increase. And finally, the excess generation capacity, E, will be equal to the difference between the nameplate capacity and the hourly demand, which you can also call the N for renewables, if you will. And there you have the two bad boys in the neighborhood. Now, let's see this in another graph, the same. We can now answer the question if we are going to be able to have 100% of renewable generation in our grids. Just matter of looking at the green curve there that follows a logarithmic increase. That means that we should have infinite installed capacity for that purpose. So it's impossible. That is the first reason. And the second one, equally important, is because renewables lack of an essential element called mechanical inertia that is only given by conventional generation sources, nuclear, coal, oil, natural gas, that will keep stable the electrical frequency. Renewables don't have that. Yeah, now let's see the US in the global context regarding this excess renewable generation capacity, starting by the nations or regions that have already passed this limit, starting by the worst of all, which is Australia, followed by Europe as an average, and then China. If you want, you can ask me why I don't trust this figure afterwards, but I would rather place China closer to India rather than to beside Europe. And the rest of the world, where you can see that the US is still somehow far from that limit, was getting quickly close to it until year 24. I hope not anymore. And finally, Russia with almost no renewables in their grids. Now, this is difficult because to see what happens with CO2 emissions with respect to the increase in renewable generation, we should ask a very inconvenient question. So I hope Mr. Al Gore is not here in this room today. Are renewables actually reducing CO2 emissions as they are supposed to? Let's see. In the first case, we will see an efficient grid or ideal grid where only natural gas is used to back up renewables. In this case, the increase in the fuel consumption will make that the CO2 output emissions rate, that is in tons per megawatt hour will also increase proportionally. And that increase in this case is not able to cancel or to offset the effect of reducing the thermal generation, making CO2 emissions, capital E above the red line below, significantly drop. But this significantly is with respect to the system thermal generation backup and renewable generation, but with respect to grid emissions, as we will see in a moment in the case of the United States, is insignificant. Now let's see in real world grids when a larger fraction of simple cycle gas turbines, oil, or even coal, like in the case of Australia, are also used to back up renewables, then the increase in the CO2 output emissions rate, this time, yes, is able to cancel the effect of reducing the thermal generation, making CO2 emissions to increase. And this, ladies and gentlemen, is the insane, absurd, and irrational scenario because renewables were meant to reduce, not to increase CO2 emissions. And we finally get to the United States CO2 emissions abatement attributable only to renewables. Back in 2023, the United States had a 14% of renewable generation fraction, allowing for almost 25 million tons of CO2 emissions abatement. That is, current emissions with that 14% of renewable generation fraction minus emissions without renewables. And that was represented 1.5% with respect to grid emissions. You can see how insignificant is the impact of renewables, 0.5% with respect to national emissions, and almost 0% with respect to global emissions, meaning that the planet still hasn't noticed the tremendous efforts made by the US, the second largest emitter of CO2 around the world. So all of this has been meaningless in order to save the planet, as you know. Nevertheless, the United States did reduce emissions slightly in about 450 million tons between years 18 and 23, 8% more or less. 366 were attributable to electricity generation and only 19.6 million tons attributable to renewables. This means that almost 78% of that total reduction there came from shifting from coal generation to natural gas generation, and only a meager 4.4% came from your renewables. So we can conclude this with much certainty that in the US, renewables have achieved such a small reduction in CO2 emissions that economically, these sustainable sources have become an unsustainable solution for that unnecessary purpose, because besides to reduce CO2 emissions is not necessary. Towards the end of this presentation, of course, just two more issues. 10 years have passed since the signing of the Paris Agreement, and hitherto renewables whose generation has more than quadrupled have not been able to reduce CO2 emissions, which have risen as business as usual. And yet, this increase has not been able to prevent a decline in global temperature, a trend only disrupted by the Hunga Tonga eruption effect and the 23-24 El Niño event, and not by the, for the US, no longer evil CO2. Even so, and this is only until 2024, of course, the US persevered in the attempt to flatten the CO2 curve with renewables and damaging climate policies. Pointless efforts, since in this period, for every megawatt hour of cogeneration capacity decommissioned in the US, 3.3 megawatt hours of that same capacity have been built in China and India. And for every ton of CO2 reduced in the US, 7.3 tons have been added by these two nations, while the growth rate of their total generation was more than 13 times higher. In the end, what renewables have only brought about in the West are high and ever-rising electricity prices coupled with taxes, regulations, subsidies, along with grid instability. All of these have caused harmful economic consequences, namely loss of competitiveness, abrupt investment break, capital flight, industrial exodus, inflation, unemployment, wealth poverty gap increase, and economic growth stagnation. All of this deeply experienced by you in previous administrations, but yet without any measurable impact on climate whatsoever. While Western governments continue a kind of Operation Epic Fury against CO2, launching destructive energy policies, aiming for a net zero utopia, and in the process, throwing their nations off the cliff in the name of saving the planet from a known problem. I'm sorry, but I must say this properly. Just a second. The United States, with President Trump's farewell to climate change, decisively chose once again the path of sovereignty, energy independence, and prosperity. There you have. Apart from becoming a sparkling beacon for the rest of the once free world that has progressively been captured by the evil forces of globalism, wokeism, and socialism, disguised as climate saviors. And this is the end of this presentation. Thank you so much.
We'll check. There we go. We'll take questions. I just wanted to say two things. He showed Einstein. Einstein famously said, a definition of madness is doing the same thing over and over again and expecting different results. That's what adding more and more renewables is to the claim that we're going to solve climate change or that we can provide reliable electricity. It's madness. And the second thing is, I think Paul Ehrlich thought he was getting over on Julian Simon with that bet. Remember, he made it in 80. The bet was up in 90, but he thought we'd all be gone in blue steam in 89, so he never thought he'd have to pay off. There you go. Okay, ready for questions. Let's see what we got here. Okay, first question to you, sir. Please, we got a microphone coming. Identify yourself and ask it to a person. No. You.
Oh, is that
this gentleman right here.
walks right by?
We'll go back to him, but
yeah, I'm Dennis Bussey. I live in Lexington, Virginia. I've been to 10 of these conferences. There's two basic things that I have learned from these conferences. One of them is that I won't use the term climate change because I don't know what it means. I think it's very confusing to me and a lot of other people. And the other thing I've learned is that if I find anyone who is either A, concerned about their carbon footprint, or B, is interested in having some government have some policy that would design to mitigate the air temperature by reducing of combustion of fossil fuels, they would fall into one of three categories. Number one, they are not informed of the science of man-made global warming, or they wouldn't believe that. Or two, they are concerned about this thing, but they are a little concerned about talking about it because they will be criticized by everybody, including their children. And three, they understand that there really is something wrong with this, but they have an ulterior motive other than something other than mitigating the Earth's temperature. So in other words, they're either ignorant, they're cowards, or they're corrupt. So anyway, that's my question is, what does anyone in the panel think of my perspective? And then my second question, all these people called Ehrlich, Gore, Turner, and all the presidents that preceded President Trump, which category do you think they fit into my three choices?
well, he asked it to the panel, but I'm going to direct it to a person because we need to keep it short.
Well, I can't disagree with what you say. There are people that are just permanently wrong, and they insist on it. And the problem is that the people who should know better or do know better, fail to challenge the people that don't know anything and insist on being wrong, like Paul Ehrlich and Gore and everybody else. And so we see this in climate, because look at how few people are on our side. I mean, and actually working to fight, the people that are purposely wrong. And it goes for politicians. I've been working on these issues for 36 years now. I still can't find a Republican politician past maybe Jim Inhofe, the late Jim Inhofe, who was actually interested in any of the science. I'm not interested in the science, but I've been forced to be interested in it because of all the lying. But most people are just not like that. And, it's easier to go along with the crowd than it is to, So I don't find fault with anything you said. It's just, the whole thing is just kind of frustrating to me, because we're the only ones working on this to correct it.
I think Lamar Smith might have been interested in the science as well.
Yeah.
Yeah, I agree with what Steve just said. And you asked about, the politicians. If you go back, just looking Republican, you go back to George H.W. It wasn't an issue with Ronald Reagan, but George H.W. Bush. He's the one that signed the Rio Earth Summit Treaty to appear green, to try to win the election against Bill Clinton, and to try to, satisfy his critics. Didn't work. We ended up saddling us with 33 years of the UN net zero climate agenda. Then you fast forward, Bob Dole, I don't think it was really much of an issue, but he would probably lean skeptic. But then George W. Bush comes in 2001, and he's all in on the science. He talks about how he's going to solve global warming. They rubber stamp all the UN reports. He funds it all. Now they always say, oh, well, he didn't, he didn't advance the treaty. He had the same policies basically Obama did, unless the developing world got involved. But he didn't really fight back against it, and they allowed it to live and fester. I'd put that more on the coward side. Mitt Romney, when he was nominated, he was all in. He had some of Obama's team members work for him in Massachusetts. He was a believer. John McCain would have been the same way. He was a co-sponsor of legislation. It really wasn't until Donald Trump came that we had a truly skeptical nominee, and he was instinctively skeptical. And the most important thing about Trump, I alluded to this, is he reframed the entire narrative, which makes it more comfortable for people to join him. Think of what DeSantis did in Florida. He was the only governor that stood up really in an active way to the whole COVID lockdown, Anthony Fauci. He gave cover for all these other Republican governors. So without that cover that that DeSantis provided, a lot of Republican states wouldn't have turned against mask mandates and lockdowns. Same concept with how Donald Trump has changed public opinion and allowed other politicians to finally join. They were too timid. When I worked in the Senate, we had Republican conservative senators, staff saying, we don't want to support Obama's cap and trade, but we have to be careful because we don't want to seem like we're against the environment. So they would never challenge the science. It was just cowardice. So, but thanks, good point.
I'm going to defend one other governor. Kristi Noem did not lock down South Dakota, and I went there.
Yeah, I don't want to.
I traveled during COVID.
But okay, not to disagree with my moderator. However, the state did not lock down, but if you go back and look, and this was provided by people in the South Dakota, she actually supported the lockdowns, but the state wasn't going to do it, so she went along with what the legislator did. So yes, you're correct that she was outspoken, but she wasn't initially for it. So it's a technical point. But yeah.
Okay, second question. This gentleman here, and then we're going to, if there's some on this, because I want to try and hit both sides. Limit statements, one question each, and directed.
I'm Francis Menton, Manhattan Contrarian.
Oh, that's
Mr. Pollock, you're from Chile, and I know Chile has just gotten rid of a left-wing president and elected somebody who's described over here as right-wing, but maybe could you tell us where he stands on these climate issues, and is anything going to change there?
Hello, Francis. I can't see you.
He's over here, way over here.
Yeah.
the lights are in his eye.
What do you have to ask
He asked about your new president.
Yes.
Is he still by climate alarm?
Yes. Well, look, what I can say about President Cast is that in all his program, I would say that the only part of his program that is absolutely from the left is in energy. He promotes renewables, he promotes green hydrogen, and he promotes batteries, backup batteries. So in that point, I would rather say that he's leaned to the left. And of course, he's worried about climate change. He speaks very little today about that, but I would have to see. I don't know. He's been in office 1 month, that's all. So we must wait. I hope the best for him. And he is actually from the right. I don't know how far to the right he is. That is my concern. Just hope the best. But up until now, I would see everything with extreme caution.
Okay, other questions? Well, we'll get you then. This young woman right here on the end.
I didn't know if you were still taking questions from the.
Yeah, we got a couple more minutes.
Okay, great. My name is Meg Young. I'm a board member of Green Oceans, which is a coalition of community members. We're trying to fight offshore wind in Rhode Island. And being in Rhode Island and with our neighbor Massachusetts, you can imagine that, you know, we're facing all kinds of wild reactions happening with our governors trying to pick up the lack of funding and momentum to keep the green energy agenda alive, which they're going to saddle the citizens of the states with. But my question is for Mr. Pollock. Your talk focused a lot on the science, which I really appreciated, and I wonder if you could speak a little bit to how some of the capacity factors really increase the rates, because the ratepayers, you know, our leadership is just touting this cheap energy, and all of our citizens are getting hammered with these really high power rates, electricity rates, because have so much renewable, cheap energy. It's really terrible, and it's very hard to get that narrative out there. Nobody wants to hear it.
Most expensive free energy there is.
Sorry, the specific question was what's going on with the capacity factor, I understood?
How it affects ratepayers.
How does it affect ratepayers, wind and solar? Yeah.
The capacity
Yeah,
factor.
Well, just
Yeah, no.
Pushing solar
I
is
believe I believe I understand your question. Look, what I didn't mention in the graph I showed with the logarithm increase, if you remember, the capacity factor follows an exponential decay after a certain limit. That is what the renewable facility sees, that its capacity factor, he may have made an assessment to invest in that business, pretending that the capacity factor is a weather parameter. But beyond that limit, it leaves being a weather parameter and starts following an exponential decay. So that is directly associated with the increase in the price of electricity, because what happens is that beyond that limit, the system must finance that loss of electricity, because otherwise you wouldn't have the possibility to dispatch any electricity to the grid. So you must finance that loss. And that is the biggest reason why. So what I show today here is in a nation scale. But if we go to specific states, for instance, New York and California, I would think that you have largely passed that limit, especially in California. And we should have to see that to establish why exactly the rates of California are the highest in the entire nation. I would believe it's because of that. You have too much installed capacity. There is very little capacity factor. I don't know if I answer your question more or less.
Every time you add any wind and solar, it's since you've already reached the capacity factor, it's just add cost, not reduce, not increase energy. And I want to say, wind and solar are the cheapest forms of free energy since nuclear was supposed to be too cheap to meter back in the 1950s.
Yeah, I think it adds to some of the other panelists' points that the money's coming. Like I think with the expense of the power, we actually will all be alive. And I'm hoping that this will come and be published so that people can understand what's happening to their rates.
I never underestimate the stubbornness and venality of politicians. Back when 20 years ago, I wrote a report on how vital coal still was. And I said, look, they're going to run into the point where they'll take coal offline, the grid will become unreliable, and it'll slap them in the face, and they'll stop taking coal offline. The grid has become unreliable, more blackouts than ever. They're still taking coal. So I was wrong. They can continue to be stupid and deny physics. Okay, one more question, maybe two. This gentleman and then this gentleman.
That's two, Sterling. That's two questions.
Yeah.
Hi, I'm Craig Richardson with E&E Legal. I was giving away my age. I was 6 years old when the population bomb came out. But since I was a latchkey kid and raised myself on movies and TVs, what is ingrained in my mind, and I just looked this up to the Ehrlich guys here. So, by the way, I don't want to give away the movie, but Soylent Green is People. That came out in 1973. I was 11 years old, and I just looked it up. The year that this was all happening, 2022. So it was a 50-year prediction, but it also said that that movie kicked off what became the dystopian kind of movie. And I know that CFAC, and I had a cameo in the second one, so you all did movies. And I think Steve made a very valuable point. Yeah, we can win the science, and we have a great presentation this morning, but they've got this, I call them conspiracy facts now. As a congressman said recently, we need a whole new set of them because all the last ones proved true. But we need to get into this, and I'd like to comment because CFAC has done the movies. I mean, how are we going to try to translate? They're wonderful presentations, but how are we? Because I think they're great. And Mark, you're funny with the hat on in the first movie, and Steve, you're great. I mean, we have the formats, but how are you guys going to do another movie? How are we going to address that? I mean, Ehrlich wasn't isolated. The whole thing was, he was part of a general movement. He was fun. That's why they give him all the awards. How are we going to try to get to that level? I mean, we're smart, we're funny. CFAC's done, your group's done enough of that. And my only other question is, Mark, if you were number 2 on DiCaprio's list, who was number 1? Was it you, Steve? Or?
Actually don't remember that. It could have been Inhofe at the time. When he was the chairman of that committee. So I know he was always rated number 1 because he had the power of that committee. So we have no plans for any immediate movie. We've talked about doing shorter segments and then piecing it all together because the world is really, it's especially with social media now. And there's actually going to be the next generation of young people, which is fascinating. There's going to be a panel tomorrow with Chris Martz, the meteorologist, and Lucy Biggers and Linnea from Heartland and others. It's amazing what, I'd like to see what we could do with young people to get out there and actually try to really make an impact. And we're seeing that on social media now. I mean, as the CNN pollster, Harry Etten, said, climate concern in the United States has dropped to levels not seen since the late 1980s. And this is before, right about the time the UN formed their panel. And it's amazing. And again, I think that is because of the narrative flip and also because of COVID. So if you want to thank someone for really just bringing climate change down, thank Dr. Fauci. There's science. Thank you, Dr. Fauci. There's a reason to thank him. He destroyed any trust in institutions and appeal to authority. So for that, Fauci should be commended.
I just, we don't have time for another question. I just want to say, look, we're doing this through short videos. Kids don't go to movies. Kids aren't seeing things at the theaters.
Yeah,
they watch YouTube and TikTok and stuff like that. And Linnea has made a series of videos that have garnered over 2 million views on climate and energy. That's the way you got to reach them today. Thank you very much. Give our speakers a round of applause, please. And then move down to the main hall where you'll have your lunch.
Yeah, I know. So I just thinking about it. I misspoke. I shouldn't have corrected it because I was wrong. Number 1, and Vegas bad. Yeah.
right, ready? 3, 2, 1. Double check your audio settings going into the stream.
I just don't hear it through the headphones.
Oh. That's weird. I was just hearing the files.
I mean, I see it level. Yeah, I'm not hearing that. I'm just not hearing it through the headphones.
Plug the headphones into the Focusrite, maybe?
What's that?
I said, is there a place to plug the headphones into the Focusrite? But you need a 1/4 inch adapter. Julian, I need your 1/4 inch adapter. All right, never mind. Hey, that guy looks familiar. Sorry, I forgot to put mine back in my case. It's still on my desk when I was using it at the shop last.
Okay, go ahead. Let's do like 200 milliseconds. 200 milliseconds of delay. Just on the screen.
Ready? $500. Ready? Cool.
It's hard because I'm seeing you over here, and I'm seeing you on the screen, and I'm hearing you in the room. Yeah. Through the headphones even. Oh. It's really, really close.
Hi,
How you doing, sir?
Doug Dominich. Good to
Yes.
see you again. How are you?
Okay. There is no pointer. Okay.
I know. Honestly, it fooled me for about the first 30 minutes. I wasn't paying close attention. I know. They got me.
Next generation won't know what that is.
Right.
Where's my library?
We're supposed to be international. We've got 4 Americans on this panel.
I know. Oh. Still buy real books.
Hey, I do too. Believe it or not. I do enjoy
Okay,
it.
I'm just trying to get out of the way.
Oh, no, it's okay.
Everyone thought,
Same place?
right. You know, it's distinct enough,
It's cold in this room.
It is.
Right, there you go.
It's cold outside too.
Yeah. Yes.
Yeah.
Weird. Has to hang on to what he talks about. Yeah.
Yeah, you get a new one.
Man, that drives me nuts.
Yeah, it never varies. It's always the same. Steady march into summer.
I had a guy who got really mad at me in the comment section of one of our climate realism articles, because I said that, oh, we have snow extent in the winter in Michigan, or in a certain part of Michigan hasn't really changed much over the last 80 years. And he's like, I remember when I was a kid, the snow was always on my shoulders. And
Yeah, how tall were you?
yeah, and he's like, it's definitely, it never snows the way it used to snow when I was a kid. So I pulled the data, it's in the article, but I sent it to you again. He's like, here's the raw snow measurement data for Michigan.
Then ask how tall he was in 1960 versus. Yeah.
Different events.
Yeah, I remember when snow was, this high in Delaware, but then again, I was only.
Yeah.
So the order is Anthony, Jonathan, and me.
It'll be Anthony and then you and
Me
then
and Jonathan, okay.
No.
Hello.
So I'm assuming like I have very honest presentation except for like the way that like
Yeah.
or like the thank you.
Yeah. You have, sorry, real quick.
Do you have anything? Yes. Oh, is that?
He has it all scripted. I'm not sure how that works. I do that for the podcast.
Yeah. The worst thing about doing this today is I totally lost my voice on the travel.
Yes, sir. Yeah.
I struggled to get back.
But anyways, excuse
After this session,
Yeah, no problem.
I was complaining we don't have an international session at 4 Americans.
Yeah, because the right. They take a global perspective.
There, I will show them after the clubs.
Hi, been saying your academic places, DDP, for instance.
Yeah,
Yeah. So waiting to see where it's gonna be this year.
I'm not sure.
I know, they haven't yet announced it, usually they announce it.
You might ask Willie Eschenbach.
I
Sometimes
asked him that, and he
he
said.
does not know.
No, he doesn't know.
Oh, if he doesn't know, then
It's a secret.
yeah, that's,
Is that Douglas for disaster preparedness?
yeah. It's either Las Vegas or Tucson. My guess is it'll be Las Vegas because it was Tucson last year. But there's no guarantee that it follows that theory.
The deal was that in the evening when we had dinner, it's going to be a red wine. You had to help with your friends.
Is
But the lights were
Joe going to us?
Yes, yep. He was at the last one, yeah, I was there.
You got Eric that reached the sun. Well, you don't do the travel world. Very nice. And their specialty is always good, winter and rainy. Pretty much from southern France. Southern really good stuff. Good juice.
Well, at least in this room, you can see the stuff on the bottom because it's elevated.
Yeah.
Yeah, they don't make good money. All the way.
Did you end up having a hard time getting out of that resort in Pennsylvania?
No.
No? I people had canceled on me when I was trying to get there, so they had
Well,
to.
see, I had driven.
Oh,
I had my
yeah.
own car. How you doing? Good to see you again. Nice to see you again. Yeah.
Just the ones. Oh, you know.
Yeah.
Yeah, I drove in, so I drove out.
But Uber would not go in there. They would like accept your thing, and then they would cancel it before you even got there, like they realized that.
You said you
No, I didn't think so either, but.
We need to be in a quiet place. Hold on a second.
Yeah, so.
Oh, heck, I forgot my, I gotta go back upstairs. I forgot my phone.
And getting to the gate like seconds before you was the rest of I wish I'd stayed overnight.
Well, I almost had that at Memphis, flying back to Rouge, last leg hotel. And I got to the gate and I said, I'm got a ticket.
Where should I sit? Who's going first? So I should sit on the inside.
She said,
Oh, you're sitting there, so where do I sit? Well, you're going before me.
Well, it doesn't matter, we gotta get.
Can you get by?
I get. Well, and then you're gonna get by when I get back to
That's true.
Anthony.
Just trying to be careful.
But I got this thing, and she said, I said, I got a ticket to the flight. And she said, I'll be sorry, I'll pass it to the back door. Let me go close the door, and I'll be able to. Did you know what? Let over, close the door. Push it, they pushed it back. I watched the plane, like, I came over and said, you're going to show up at the Mars plane. No wonder Republic's going out of business. So we can have it on time.
I forgot my phone. Anthony, did they get your presentation?
I want to see how this fits. Still got a couple of minutes here, right? Do these mics bend? I think they do bend. Yeah, if this goes up higher and this way, then I think there's space. And then, not bad. Let's try. That's not bad. Yeah, lapel mic would be a lot easier than this. Do they have them? Lapel mics.
They had them earlier. I think she's gonna go look for them.
Okay.
Of course, then that means we've got to switch them over. And I only think they have one.
I see. Well, I got this, I think,
Carries this thing, so I'm gonna take it out.
bent around the screen here. And then this can bend forward. And then I can still see the words here. That should work. What do you think? Teleprompter like Donald Trump.
There you go. You just have to keep up.
Just got to keep up. That's the key. Yeah. Oh, you've got lapel mics. Awesome. That'll make it even better. Then we can take those out of the way.
You don't have anything to say, you're pretty proud.
Okay. So it doesn't hear me.
I'll control it.
And then you'll control the levels and so forth.
Yeah.
Great. Where does that go?
This just goes on your belt. All right, you're all set.
That's it. It's off, and it's off now.
Yep.
You'll turn it on once I go up.
Yeah. You might want to take your badge off once you get back on stage, so it doesn't like angle on the mic.
Maybe I'll do that.
Oh, you scroll it. You scroll the. Okay.
Okay. I'll be right back.
Thanks. Thank you.
I disagree.
And then, will Anthony need a microphone, or is he just going? No worries. Thank you.
just gotta let them know that.
Yeah, I'll go. I think the AV people will kill me.
Anthony Watts, Weiss example. My name is Anthony.
Yeah.
That's an old. That's what you sell.
Anthony, 1, 2, 3, 4. Thank you.
We're still gonna go with David first. We're still gonna. Okay. Is this thing working? Okay, awesome. I'm going to apologize first, you guys. I'm losing my voice for no reason at all, and I'm trying to find it, but if I sound a little hoarse and weird, that's why. So welcome to this panel, which is on problems with temperature and climate records. So that'll cover your temperature records, precipitation, how they all relate, you name it. If that's the talk that you were looking for, you are here. If not, the one you're looking for is downstairs, but we are very glad to have you anyway. So I'm not going to spend a whole lot of time introducing this one. We're going to kind of jump right into it, but I am going to introduce all of our speakers. First, we are going to hear from David Legates, who is a climatologist who is currently the Director of Research and Education at the Cornwall Alliance for the Stewardship of Creation. He is a retired professor of climatology in the Department of Geography at the University of Delaware, an adjunct professor at the university's Physical Ocean Science and Engineering program in the Department of Applied Economics. So he was also an official climatologist for the state of Delaware and the Deputy Assistant Secretary of Commerce for Environmental Observation and Prediction at the National Oceanic and Atmospheric Administration. We put as many words into this intro as possible. And he was detailed to the White House Office of Science and Technology Policy as the Executive Director of the United States Global Change Research Program. And I could go on and on, David, because your background is very, very impressive. But I will also say that you are widely published and referenced in climatology research, and you have focused much of your recent work towards improving our ability to accurately measure precipitation. And you point out what has gone wrong with the way that that data is measured now. Anthony Watts is a senior fellow at the Heartland Institute, but most of you probably know him as a meteorologist who operates the award-winning, most viewed website in the world on climate science, which is whatsupwiththat.com. I think that website brought a lot of us here. He had previously worked both on air as a television meteorologist and also behind the scenes in technology. He's created weather graphic systems for television, special weather instrumentation, and has co-authored peer-reviewed papers on several climate issues. Most recently, Anthony has been working to reveal the issues with surface temperature measurement stations that have been used by official government climate record keeping, and has built his own measurement stations, which are actually sited away from urban heat, which is just crazy. That's just not how it's done. And finally, we have Jonathan Cohler, who is a software developer who works with artificial intelligence and climate science, and has been able to demonstrate the significant bias that large language models from major companies promote when it comes to the data and facts surrounding climate change. He has recently co-authored a paper which utilized artificial intelligence to reevaluate the effect of anthropogenic carbon dioxide on warming, and proposes that the IPCC assumptions about total solar irradiance values destroy the popular model's ability to accurately predict climate change. And I'm very impressed to say that he's also a very accomplished conductor and classical clarinet soloist. Those are our speakers today, you guys. I'm going to step aside here, but I'm going to say as a quick reminder, we're going to have Q&A at the end. Please, if you can, keep your questions brief and to the point, and make sure that there's actually a question attached. You know, I know that we have a lot of great scientists and very intelligent people here at this conference. And unlike climate alarmists, we actually like to debate and discuss the science on these issues. However, we're limited on time here, and this is not the time to share a dissertation or the body of your own research. So that's what the coffee breaks are for and the meals. So please leave it for that time, you guys. I'm going to pass it over to David.
Thank you very much. Can you hear me okay? Okay, good, because I'll just pretend there's 300 people in the room and pretend like I'm teaching. In any event, I'm going to talk today about precipitation. Usually the temperature gets all of the action and everybody's interested in temperature. I spent most of my life working with precipitation, so therefore that's what I'm going to talk about. The interesting thing about measuring precipitation is it's a little bit different than every other variable. Every other variable, we're trying to look at the impact it has on the energy or making things move. What we're looking at in precipitation is we're actually trying to collect mass. So it stands to reason then that a rain gauge probably doesn't need to be much more than a tin can and a dipstick. And in fact, you'll find that that's primarily what we have done for a long period of time. In second grade, when they start to teach people about meteorology, one of the things they do is they repurpose a 2-liter bottle, and we have an impromptu rain gauge. And so, you know, you can make it pretty much out of anything. Sometimes they abuse the privilege, but nevertheless, the National Weather Service came up with the standard 8-inch rain gauge that they used for years and years. And if you look closely, I don't have a pointer, but you can see there's a dipstick. There's essentially a funnel. It is no different than a tin can with a dipstick associated with it. There's other ways of measuring it that we use from time to time, but they don't usually get into the widespread use. These are Belfort rain gauge or a Fisher-Porter rain gauge. These are based on measuring weight. So how much have we collected, and we convert it by weight. This is a Giaenor's weighing gauge, which is an interesting design, which has a electronic string that goes down the side, and you pluck the string, and the frequency with which it vibrates tells us how much energy there is. You can see we have optical rain gauges, so as the water intercepts the line of sight between the emitter and the receiver, we can estimate the rainfall rate. We have hot plate precipitation gauges. The idea now is to take the one plate face downward and one place faced upward. The one faced upward gets caught with rainfall and snowfall, and it has an additional demand in trying to evaporate the moisture, and so you can come up with a rainfall or snowfall rate that way. We have acoustic rain gauges because the sound of rain on plastic or the sound of snow on plastic somehow can be converted to rainfall intensity and frequency measurements. But most of them that we've found, and we've been taking measurements for years and years, really are nothing more than tin cans with a dipstick. Now, I'm going to go through a number of these as I talk, because this is essentially the problem I had. I'm trying to put together a global climatology of precipitation. And you'll notice different countries use different gauges. Almost every country has their own design and their own concept, and they're at different heights. Some are buried partially in the ground, some are on stakes. Generally, the higher above ground they are, the more likely there is to be snow to keep them out of the snowdrift. And this is the problem. When you go across from one country boundary to the next, you get a discontinuity because it's one gauge over here, it's another gauge over here. They're measuring different things, and so they have different errors associated with them. I should have put a faster speed on this. In any event, there you go. And my favorite, the one from the Netherlands, because if it's not raining, it doubles as sort of a beer stein. The interesting thing about rain gauges is people think they're everywhere. They're not. They're only in places primarily where we have developed countries, and they're generally where people live. So you can see this is where developed people live, developed countries. Generally, that tends to be in lower altitudes. There's a lot of underrepresentation in higher altitudes. There's a lot of underrepresentation in low latitudes and high latitudes. So we don't have the tropics covered. We don't have Antarctica or the Arctic well covered either. And as you can see, most of them are over land areas, very few over the oceans. So they are biased spatially as well. Now, in the United States, we have two types of networks that we use primarily. One is the National Weather Service 8-inch rain gauge, which you can see is a design that's about this high above ground. You can see that it's designed that way so an observer can come around every hour, take the top off, look in, take the approved National Weather Service dipstick, measure the amount of precipitation, pour it out, and set it again for another hour measurement. The one on the right is a cooperative network. These are measured about once a day. And so these are all over the place. Farmers and so forth will get one. I brought one just for fun because I had nothing else to do. So here it is, and now I can count it off on my taxes. But in any event, there's about 13,000 rain gauges associated with the conterminous United States. And if we pretend that about 3/4 of them are the co-op, that is a 5-inch gauge orifice, and about 1/4 of the National Weather Service 8-inch gauge orifice, the question is, how much area are we really covering in terms of rain gauges in the United States? So we can say that the 5-inch orifice diameter is about 19.63 square inches. The 8-inch is about 50.27 square inches. We can do our multiplication, which is left as an exercise for the student. And you can see the total area that's covered is about, not quite, 2,500 square feet. Compare that, for example, with a soccer penalty area, which is just under 10,000 square feet. The Major League Baseball diamond between the 4 bases, which is 8,100 square feet, the National Football League football end zone, which is 4,800 square feet, and NBA basketball court, which is 4,700 feet, or between the NHL blue lines, I think I've got every sport necessary, and it's 4,250. So you can see next time you're watching a sporting event, realize that the field or area on which, pitch, whatever, rink, on which the people are playing is actually much larger than the area in the United States that we actually measure rainfall. And remember, the United States has a lot more measurements than most other countries as well, much denser network. Now, you might think that the biggest enemy of a rain gauge is in fact birds. And we've done all sorts of things to try to keep birds from sitting on the edge for obvious reasons, but that's not really the biggest problem that we run into. In fact, the biggest problem is not sighting, and in fact, some of these sighting characteristics, I would argue, are probably better than the way we actually really do it. And the problem is, it's the effect of wind. Wind on a precipitation gauge, again, we're trying to measure mass. So as wind encounters the can-type rain gauge on the left, you can see two things happen. Three things happen. One is as the air hits the gauge, it's forced to flow up and over the top of the gauge, which gives you a slight updraft that takes place. Secondly, there's a compression of the wind field, so the wind moves a little bit faster across the orifice. And third, there's a pressure differential between the air at rest inside the can and the air in motion above it. And all of this means that the precipitation is going to be underestimated. It's underestimated quite a bit with rainfall, but really dramatically with snowfall. So what are we to do? Well, one thing we can do is put these in the ground. And in fact, you can see some places do that. These are pit gauges, as they're called, but no operational group likes to deal with them because imagine trying to get in there every hour and take a measurement. It's just not, you would like it right up here where you are. So what they do is they put some form of shield on it. In this case, you've got a knife or shield. Uh-oh, he's coming towards me. Okay. Sorry, I thought you were going to, anyway. So you can see there's a knife or shield, and the idea with a shield is so that it separates the air above from the air below the orifice of the gauge. So you don't have this compression of the wind field, you don't have updrafts, and it works fairly well. And you can see that snowfall with a shield and rainfall with a shield are better, not perfect, but they're better than what they were when we just had simple rainfall or snowfall. Here's a knife for windshield. The Canadians used quite a bit. They were originally designed in copper, and then they found out people were stealing them. So they made them out of aluminum, and apparently people don't steal them now, although I don't know why aluminum sells well, but nevertheless, aluminum doesn't get stolen. But there's other designs. The Soviet Union, they came up with the Tretyakov shield, which are fixed slats, and they have the same effect. And in the United States, we have the Alter shield, which is sort of movable slats. And they both do the same thing. And you can see here is a Tretyakov windshield in the wild, as they say, and an Alter windshield that we use in the United States. Second problem, not just wind, is wetting on the internal walls of the gauge. The idea is that that water sitting on the internal walls of the gauge should have been counted as precipitation. Never made it inside the rain gauge itself. So there's a wetting loss from the water that adheres to the outer side of the gauge. That's a problem. And the third problem is, particularly with cooperative gauges where you're only coming out once a day, they tend to evaporate. And that's why we have an evaporation pan. And you can sort of see, if you squint a little bit, that a rain gauge is really just a type of evaporation pan, except we're not really measuring evaporation. We're getting evaporation, unfortunately, as a byproduct. So what I found with a global assessment is that globally, precipitation is measured precipitation is an underestimate of the exact actual rain that falls, about 8% due to the effect of wind, 2% due to wetting losses globally, and evaporation losses about 1%, which gives us an undercatch of about 11%. The other thing you'll notice is the logarithmic wind profile, which you may be familiar with. The idea is the higher above ground, the higher the wind speed. The higher the wind speed, the greater the loss of the catch. So the problem is, if you have a gauge higher above ground, it's going to be subject to faster winds. It's going to have less of a catch than if we were to put the gauge down to the ground, which is one of the ideas of putting a pit gauge into the ground and burying it. Now, this is a conference on climate change. I have just gone 9.5 minutes, and I haven't mentioned the word climate change or global warming or anything like that, but I would be remiss if I didn't. Now, this is where the problem always starts, because here you can see the Times comes up with an article that says extreme rain and flooding will rise due to climate change, study says. Heavy rainfall events will be 4 times more likely in 50 years' time, putting homes and businesses at risk. And the argument is for 2 reasons. One, climate model, I've been told this time and time again. Climate models say this is true. That must make it true. Secondly, I'm told that what happens is with these data is that the Clausius-Clapeyron relationship means that as temperature goes up, you get more water in the atmosphere, and therefore it stands to reason that when you get condensation, then the precipitation falling out of it is going to be greater, and so we should get heavier rainfall rates. So it stands to reason warmer temperatures, and because the models say it has to be this way, that we should be seeing an increase in precipitation over time, and indeed, they'll show you a graph like this. This comes from NOAA's Climate Extremes Index, and this is, as you can see, the extreme one-day precipitation event. So I went back and I got the current data, and you can see here it is in points, and they plot a moving average, and sometimes I've seen it plotted like this, and then truncated off at about 1950, so you see a nice rise, and yes, in fact, that's rising, and that fits perfectly well with the carbon dioxide curve, and therefore greenhouse gases must be inducing this increased precipitation, because again, the models tell us so, and because it has to fit the Clausius-Clapeyron relationship. But I'll tell you, I took one look at that and I laughed, because I know what's going on, and you may know what's going on. And if you don't, I will show it to you, because it's one of those things, once you see it, you can never unsee it. So here's what happens. What are we looking at, first of all? On the left axis, we have percentage of the United States with a greater than normal proportion of precipitation derived from extreme one-day precipitation events. And this is equivalent to the highest 10th percentile. So you take all of the data, you figure out what are the heaviest 10% of rain days, and you say, are we getting more of our rain from the station? If so, we count the station. If not, we don't. We do that for each year. We found out how many stations we have, and our expected value should be 10%, because on average, we've got the highest 10th percentile, so this should average out to 10%. And again, you can see that it's a little bit lower and a little bit higher. But what I know is the following. Through 1990, we used the standard National Weather Service rain gauge. It's located about this high, subject to wind effects, has a person every hour comes out, takes a dipstick measurement. So there's wetting losses, there's evaporative losses too. But the National Weather Service in about the early 1990s said, why are we wasting this? This is bad use of our manpower. What we really want to do is we want to upgrade to more electronic means. So what they decided to do was to get rid of these and change it with what's called the ASOS gauge. ASOS is Automated Surface Observing System Rain Gauge, which is a tipping bucket gauge. The way the tipping bucket gauges work, you can see there's a little, I don't have a pointer, but there's a little tipping bucket that goes back and forth. Every 1/100th of an inch of precipitation causes the bucket to tip. There's a little reed switch that measures it. We get a real-time measurement of how much precipitation is falling when that reed switch tips. We don't have to wait for an hour, or worse yet with the co-op data, we don't have to wait for the end of the day to figure out a daily average. You know exactly when that rain fell. We can do sub-hourly values. Makes lots of sense. So the idea then was we put these out at all of our first order weather stations. And now you can see here is one. It is much closer to the ground. We don't need to have people out there every hour. We just need a technician to come out every month or so to make sure it's working right, lube it up and so forth. And so it can be much closer to the ground, which it is. Well, remember, closer to the ground, lower wind speeds. Lower wind speeds, it's going to have an increased catch. Then we do the second thing, and that is put a windshield on it. So now we're going to get a much more efficient catch to this gauge than we were getting with the 8-inch orifice gauge sitting at this height. So there's going to be a discontinuity in the record driven by simply changing instrumentation from the National Weather Service standard 8-inch gauge to the tipping bucket gauge. The original design was to heat these things up really hot so that when snow or ice fell on it, they would melt. And you would just measure it just like you did with rainfall. The problem is it didn't work well at all. It started to evaporate, and there were all sorts of correction equations that said, you know, you got to cover up 30, 40, 80% of the precipitation that fell. So we now use these kind of things to measure snowfall. But snowfall is not usually the heavy rainfall events, not the heavy precipitation events. And so as a result, we're not really going to be concerned with these. It's really the tipping bucket gauge that's going to be controlling that previous curve. So let me go back to the data. Now, do you see it? If you don't see it, I'll help you out a little bit. Here you can see the pre-National Weather Service modernization data up until 1990, and you can see that curve is as flat as a pancake. I mean, at that R squared level, I couldn't get an R squared that low if I took a random number generator. Okay, so there has been no trend in this data from 1910 to 1990. Then if we go after the National Weather Service, the post-modernization, and we plot, you get another flat curve with no trend. But what happened? There's a jump discontinuity in here because we have a more efficient rain gauge. And because we have a more efficient rain gauge, that has increased that number by a little over 4.5%. So what you're seeing in the record is not a climate change signal that we could attach to greenhouse gases. What you're really seeing is a problem associated with gauge measurements. And that was the problem trying to come up with a global estimate of precipitation, was how do we do that kind of stuff? And because we've got gauges here, gauges there, and now worse yet, within a country, we've got changes that are taking place that makes it look like there's a climate change signal when in reality there isn't. The study goes a little bit deeper. It says, well, notice in the Northeast, that's your biggest difference between the pre and the post National Weather Service modernization. What's going on in the Northeast? Well, it turns out the Northeast has a higher number of National Weather Service gauges. So ASOS appears much more frequently up there. The gauge change is dramatic. And you can see for the Northeast region, the difference has been a change of 10%. But they also notice, mainly National Weather Service gauges. They also notice down here in the Northern Rockies and Plains, the Southwest region, the West region, the Northwest region, these numbers are fairly low. Well, if you read the fine print, what they tell you about this index is that in these regions, there weren't many National Weather Service gauges. So they took a lot of the cooperative network and added them in. Remember, the cooperative network didn't change. We still use that same type of design, and we still use it today. So those numbers should be lower because we've got gauges that didn't change adding to the numbers, and that's why they're low. So these have been augmented with cooperative gauges. Now, back to my home state of Delaware and home of, Joe Biden, you know. In December, we came out with the Delaware Climate Action Plan. This is a 288-page of what we're going to do to stop climate change in Delaware. And you know, if we stop, we're going to be net zero by 2050. And when we do, you know how big of an impact that's going to have on the global air temperature record. Well, it's going to have a big impact on the precipitation record too, because if you read it, it says, since 1895, Delaware's annual total precipitation has increased by about 3 inches a year and is projected to increase by another 2 to 4 inches per year. Somebody needs to read this stuff before they publish it. It's not per year, it's over the whole bloody record. So it went from like 42 to 45 over that period. But this thing is a playbook. It's got all sorts of kitchen sink type of things to change and how we're going to be net zero. And any event, it's available online. But what I did was I went back to the data. Let me go back one step. This is from total precipitation from source NOAA's Climate at a Glance. So I went to NOAA's Climate at a Glance, and here are the data. And I decided, let me try the same thing. What happened in 1990? So I looked at this. This is the pre-National Weather Service modernization. There's your post-National Weather Service modernization, and there's a discontinuity that occurs right there. It's the change in gauge network that creates virtually every bit of that signal. It's not a climate change signal that you would even believe immediately would have anything to do with carbon dioxide or with greenhouse gases, because it doesn't wind up as a jump discontinuity. It winds up as a trend, if it were doing that. But you can see here that it's simply a jump discontinuity because of the gauge change. Except every time I've tried to publish this, the reviewers come back and say, you have to be wrong because the models say precipitation should be increasing. And after all, go back to an introductory text. Read the Clausius-Clapeyron relationship. You'll understand why you did something wrong. I don't know what it was, but you did something wrong in there. I didn't, trust me. And fitting a line like that is the most ridiculous thing we can do. But then again, we did that in Delaware and are going to do that. Thank you very much.
That was an interesting presentation. And I got to say, I thought temperature records were messed up. Wow. So he didn't share this anecdote, so I'm going to this little story. So I'm going to talk about rain gauges for just a second. I've deployed dozens upon dozens of them. But I heard a story once, and it's true as far as I can tell. And it just goes to show you how imprecise measurements can be out in the field. And I think it was from the Isle of Man. No, not that guy. But apparently the Isle of Man has a residential community and then the downtown area where the pub is. And there was a path that went between them. There was their weather service office somewhere in the middle of that path, and they had a rain gauge not too far from the path. And so the guys that would go to the pub would be coming back in the night along that path and would conveniently use the rain gauge to relieve themselves. And the weather service there is like, climate change, oh my God. Anyway, seriously, that just goes to show you how messed up measurements are. So I'm going to talk about some more messed up measurements. I did a report back in 2009 with the help of the Heartland Institute. We talked about serendipity and the 650 volunteers we got. Then in 2022, I discovered I did another update. Went from 89% bad up to 96% badly sited stations. And then we're now looking at ghost stations. What's been happening out there is that observers who have been, cooperative observers for 25, 30, 40 years, they die or they get tired or they move or whatever it might be, and the station gets retired. But because NOAA thinks the continuity of record is more important than the quality of record, they extrapolate data from around the station to try to fill it in and keep the station going. I kid you not. And then finally, I want to talk about my goats project in Reno, where I put together a very high quality station, a sample of which is downstairs, you can see, and I'll show you the results. So the Surface Stations Report in 2009, and many of you probably saw this. If you haven't, it's available on the Heartland website. You can download it. And here's some example stations that we found in the 2009 report. The one on the left is Detroit Lakes, Minnesota. That's at a radio station. There's an air conditioner there. That is the power transmission line going out to the radio towers. And there's two thermometers there, one of which is the old Stevenson screen, which is highly deteriorated, another problem with temperature measurements. Then Dillon, Montana, at the power generating station for the university. Not a perfect place to measure climate. And then Durham, New Hampshire, where there's station, a rain gauge and a temperature sensor right next to a parking lot. Pretty common. So the whole thing started with me having curiosity about latex paint on these Stevenson screens. You saw that one that was so highly deteriorated. Well, that was one of the problems. The whitewash on these things, you know, they put fresh whitewash on it and it would have high reflectivity. And then what would happen is it would deteriorate, it would get dark, and it would have absorption of more solar energy. And so the temperature measurements would be a sawtooth wave every time they would repaint it. Same thing happened with latex paint. And we switched to latex paint from whitewash in 1979. Lab tests that I had conducted showed about a 3 Fahrenheit difference in the Tmax and an 0.8 degree difference in the Tmin between the two different coatings. That's never been accounted for on the record. And that difference matters because the entire 20th century warming signal is about 1.2 Fahrenheit. I looked at 3 stations around my area to check the paint and found the problem was even worse. So it started out into a much broader investigation. And we looked at all of the USHCN, 1,221 stations, look at the siting standards, that the minimum standard had to be met in order to do proper measurements. In most cases, they weren't. The class 3 to 5 stations, which were the worst ones, had errors of 1 degree centigrade or more, larger than the claimed century trend of 0.7 centigrade. And so we launched surface stations in summer 2007. So what we found is that the temperature measurement network, just like the rain gauge network, is mostly broken. AC exhaust, blistering rooftops, parking lots, roads, all over the place. Air conditioners were just one of the most, it seemed like, you know, they say that trailer parks attract tornadoes, right? Well, I think it has to do with air conditioners too. Air conditioners attract thermometers. I don't know, it's just crazy. So anyway, I came to the conclusion that the US temperature record was unreliable back in 2009, and I continued to investigate it today because indeed it is. So the 2022 update, which we published, called Corrupted Climate Stations, went even deeper, and we resurveyed a number of stations that were out there, plus some that hadn't been. For example, this one in Arco, Idaho, a little town in the middle of nowhere. Where do they put the thermometer? Right next to this big blistering wall at the newspaper. And you can see that's what it was like at about 11 o'clock in the morning. Sun hits that wall, it absorbs all that solar radiation, and it re-radiates it through the day and especially at night. So it brings the Tmin way up. This one is just hilarious. This was photographed by our Heartland colleague Tim Benson in Florida at a wastewater treatment plant. And, you know, I said, air conditioners attract thermometers. Well, here's proof. Look at that. We got all those all those air conditioners in one thermometer. It's amazing that the Weather Service personnel don't flag this. It's just absolutely amazing to me. So here's the other thing about this. These stations located next to the AC units will get the most extreme bias on the hottest days when the wind is still, and because the AC units are working harder, they're going to cause a Tmax that's way higher than normal. Science. Anyhow, so we looked at the comparisons, and lots worse in 2022. 96% fail. It got worse. And I mean, it was really hard to find good stations when we looked at the second survey. The worst stations that we found were only closed after some publicity. Basically, we shamed them into closing them when we published on What's Up With That and other blogs and other outfits. That was the only thing that caused these things to be changed. Yet, when they would close them, the data still existed as ghost stations. It's like a bad penny. You can't get rid of it. So they closed the high-profile bad stations, but only after public embarrassment. Many equally poor stations with less publicity remain in the record. The solar panel conversions, they tried this. They tried to make the MMTS ones, that's the one on the post that looked like a beehive. They tried to turn those into a wireless thing. Well, I don't know if you've ever dealt with solar panels, but the only place you can mount them is below the beehive, and they heat up. They get up to around 140, 150 degrees Fahrenheit during the day because they absorb all the solar radiation. So I found one in Lava Hot Springs, Idaho. And yes, that's exactly what it sounds like. It is a station that's down in a hole which has all these hot springs where people are recreating. And the temperature sensor was right in the middle of this. And they used this as part of the climate record. It's just amazing to me that this was not flagged. But the Weather Service seems to think that having a continuity of record and an observer is more important than the quality. And they seem to be doing this constantly with no care whatsoever about making sure these stations are sited. I went to one in Grass Pass, Oregon. And I actually knew the engineer who ran the radio station because he used to work at my radio station and TV station down in Chico, California. And I talked to him about it. He says, yeah, I complained to the Weather Service about this station. This thing was on the side of a building over a parking lot. Worst sighting possible. He complained to National Weather Service to say, hey, can we relocate this? Can we do something with this? They refused. I just don't get it. So with all these bad stations out there, we get this infilling when the station data is missing. And since 96% of the stations that I found, and we've surveyed well over 1,000, when they're closed or the data's missing, they infill it from the other ones. And so we get this big hot mess of a temperature record. Ghost stations. This is something I really hadn't tackled until recently. But those red and orange dots represent Weather Service stations that have been closed in the U.S. Historical Climate Network. Out of the whole nation, you got a whole bunch of them that have been closed, yet they still exist in the record. Now, if, let's say we were in a court of law, and we tried to present data like this, to prove a point, we would get thrown out of court because the forensics are terrible. You can't, we've made up data to make a point. That would not fly in a court of law. And yet here we are using this set of records to create policy and change our lives, change our energy infrastructure, change how we live. It's just so wrong. So when I did some station surveys for a 2026 paper I'm working on, some could not be verified to still exist, as you saw on the map. The database that maintains all the locations and everything may show a station is as active even when physical verification said otherwise. Analysis of 445 unperturbed stations that hadn't been moved or otherwise disturbed showed 157 had raw data ending before 2025. Many terminated well before 2015. That means that that data, even though it's still there, has been, made up. So what's been happening is that there's been so many closures, especially the well-sited stations, and these typically are at mom and pop farms. A lot of these stations out in the Midwest are at people's houses or at the farm or whatever, and they're volunteer observers. Well, it's become kind of old hat. A lot of people don't want to do it anymore. Like I said, some people have died and moved on or whatever. So the number of good stations that have been closing is so large Now we don't have very many reference stations to compare to. And so we end up with this, like I said, big hot mess. Here's the trend that I've calculated. When I did it back in 2009, about 11% of the stations were good, well sited. And it went down from there. By 2022, it dropped to 4%. And now we believe in 2025, 2026, it's somewhere around 2% or less. And so we're ending up with a temperature record that's not only unrepresentative, but it's fabricated from missing stations. So here's how it works. A station opens in the 50s to 60s, put in a rural field, well sited. And then urban growth surrounds it. And this happens regularly. You know, towns build up, things get built, roads get paved, parking lots get built, malls get built. And then the station closes. Funding gets cut, observer dies, whatever. Homogenization, that mixing of all of the good and bad data continues. We end up with ghost data, laundering the warm bias that we have in our record. And so the official record shows acceleration, just like David Legates' presentation showed acceleration in the rain gauge data. It's just really bad. So I decided to take on a project that would tackle the idea of being able to prove a station is bad. And I built a system, which you can see downstairs, called the Global Open Atmospheric Temperature System, or GOATS. So the idea was, it answers one question. Are the reported temperatures influenced by local heat sources around the station or by the atmosphere itself? That's the most important question. So I modeled it after the best technology out there, the US Climate Reference Network. I studied their technology. I could not afford to build stations because they were about $30,000 by the time you got all of the equipment together and everything. So I came up with another idea. And I found equivalent meteorological instrumentation and sensors that came in at a lot less, around $3,000. And I built it. And I've been building them ever since. This is going on about 3 years now. We put one with permission at the Reno airport. Went to the airport authority, had a meeting, demonstrated everything. The local TV meteorologist who'd been there, Mike Alger for 30 years, a good friend of mine, he was the one that got me in there. And it was only because of his influence that we were able to do this. It's solar powered, operates 24/7. It'll work through darkness. It reports data back by cellular. And we set it up and made it run. And here's the breakdown. Now, we use a special sensor made by a company in Chicago called Sensorion. It's an SHT-35. Now, what's unique about this sensor is that it's different from any other temperature sensor out there. It is NIST traceable, meaning the National Institutes of Standards. But it's more than that. They run each little sensor through a calibration process, and they store a digital calibration curve inside the sensor chip. So, you know, it's always accurate to within 1/10 of a degree, no matter what the temperature is. And we can't say that about any of the Weather Service stuff. It's got a state-of-the-art radiation shield made by a company in Lithuania, of all places, Beriani. Their sensor shield is so good that it's been accepted by the World Meteorological Organization. So between those two things, our system becomes pretty well bulletproof. And we have a GPS sensor in it to make sure that, you know, it stays where it's supposed to be, that no one runs off with it. It's weatherproofed, it's wind rated up to a Cat 2 hurricane. And like I said, the cost is much more reasonable. So here's what we found in Reno. In 2024, we measured 366 days. It was a leap year. The ASOS, which is the station run by the Weather Service, the climate station of record, is in the middle of the airport between two runways. And because it is there, it has an extreme heat bias. It's picking up jet exhaust. The prevailing winds go from west to east. It's picking up all the infrastructure of the city to the west. All this stuff is transporting heat right through the sensor. So the overnight low was dramatically higher, 2.91 degrees Fahrenheit. The daytime high was 1.35 on average. The daily average was 2.13. On 90% of the nights, it was warmer. Same thing for 2025, a little bit less numbers. We had a technical problem with the cellular network that prevented us from gathering as much data. So that's why we only had 347, but the trend still held. And so the bottom line is that Reno has been cited as the fastest warming city in the nation by outlets like Climate Central, propaganda outlets about climate. Well, what we've proved is that it is not the fastest warming city in the nation because of climate change, but it's the fastest warming city in the nation because of where it's placed. And this is a consistent pattern that I found throughout my investigation over the past 3 years. And I've got bad stations, we've got ghost stations, we've got temperature differences between the good and bad that hold up no matter how you look at it. Siting matters. It matters more than climate. It biases the temperature more than climate. And it is the single biggest contributing factor to our temperature record looking like it's accelerating in the United States. And it works pretty well when we compare it to satellite imagery. When we find the good stations, compare it to satellite imagery, of Dr. Spencer and Dr. Christie, it's pretty close. So it gives a ground truth for their measurements. So if you'd like to have one of these, we'll set you up. You can get one for $3,500, but the big caveat is you have to have the right location. You can't just put it in your backyard. No, that doesn't fly. It's got to have at least 100 feet around the station that is clear of any kind of asphalt or concrete or buildings, shade, or other influences. And so to get one of these, and we would love to have you get one, it has to meet those criteria. Otherwise, we can't deploy it because the measurements would not be accurate. So what am I asking for out of NOAA? Pretty simple. An independently managed, network-wide quality control audit of every station out there that you're using. Seems simple enough. A gold standard data set from the best cited stations published monthly, along with the blended homogenized hot mess record so people can see the difference. Seas temperature data fabrication at GO stations. That seems like just, common sense, but then again, we're dealing with the government. Give the URCRN the clean network built precisely for the purpose of measuring temperature accurately, prominence in the monthly and yearly climate reports, and support the GO methodology as a replicable system that can be used to test these features, to test that temperature is biased. So in closing, when 96% of your thermometers are broken, maybe the global climate fever is not as bad as they say. Thank you.
Let's move these back. There we go. Okay. The emperor has no clothes. You know the story. Swindlers convince an entire kingdom to applaud robes that don't exist until one child blurts out the obvious truth. But our situation is darker because in ours, the swindlers have captured the schools. For decades, the Intergovernmental Panel on Climate Change, the IPCC, has paraded various metrics before the world as settled silence. But all of them are physical fiction. They aren't real, or in Yiddish, they're bupkis, which ironically is a real word for nothing. But many of us in this room have been disputing interpretations while accepting these lies. Is 1.1 degrees dangerous? Is the energy imbalance large enough to justify net zero? These questions concede that the quantities are real, but they aren't. They literally have no connection to reality. My talk today is based upon 4 papers. First, my 2025 peer-reviewed paper on global temperature. Second, on our 2026 peer-reviewed paper on Argo-based ocean heat content, OHC, with co-authors David Legates, Keston Green, Ole Humlem, Franklin Soon, and Willie Soon. Third, our 2026 paper with co-author Willie Soon on CO2 dynamics, currently under review. And fourth, a hot off the press preprint introducing and proving my new physical tether theorem. I want to acknowledge my co-authors, and in particular my mentor and dear friend Willie Soon, who many of you know, whose decades of courageous work made much of this possible. And I want to honor the truly seminal contributions of Christopher Essex, whose work laid the foundation for all my papers here, as well as Dimitris Koutsoyanis, whose isotopic analysis and reservoir routing papers are truly new foundations of climate science. For 38 years, the IPCC has paraded a framework that appears real, draped in equations, satellite data, supercomputer models, Academy Awards, and even Nobel Prizes. But it's a snake eating its own tail. Each of the 5 lies appears to validate the next, but the circle is actually empty. Global mean surface temperature, GMST, it's the number that has risen 1.1 degrees since 1850, and the number whose further rise to 1.5 or 2 degrees is catastrophic. But GMST was proven meaningless in a 2007 paper by Essex, McKittrick, and Andresen, unrefuted in 19 years of peer-reviewed literature. Last week, I released a strict mathematical formalism of classical science itself, which in one fell swoop proves mathematically and more broadly that GMST does not exist, it cannot exist, it's completely fictitious. A little history first. The International Organization for Standardization, which defines complex technical standards across every field of science and engineering, was tasked in 2002 with defining global temperature, but they never did. Now, ISO has defined everything from the size of a sheet of paper to how to brew a cup of tea. But they failed to define global temperature of any kind. The omission was not an accident. It was the recognition that no valid definition can exist. This is where the circle of 5 lies begins. ISO Guide 84. Guidelines for addressing climate change in standards, 44 terms, and not one of them is global temperature or global average temperature, whose variants appear frequently in the guide, but they're defined nowhere. Just to be sure, by the way, I asked AI Claude to read the whole guide. Answer: there is no definition. Okay, in 2007, as I mentioned, Essex, McKittrick, and Andresen, they went further. They proved there is no physically meaningful global temperature for the Earth in the context of the issue of global warming, unquote, unrefuted for 19 years. Why? Temperature is an intensive property. It belongs only to a system in equilibrium. You cannot average separate systems like spots on the Earth with 120 degrees C temperature differences or 800x density and 4x heat capacity difference, as there is, for example, between seawater and air. With all deference to John Clauser, unlike quantum mechanics, there is no thermodynamics at a distance. Averaging across such systems is totally meaningless. It would be like averaging all the phone numbers in Washington, D.C. and hoping you get President Trump's direct line. It's not an approximation, it's a category error. The result has no meaning. My new physical tether theorem proves mathematically that GMST, as used by the IPCC, NASA, and others, is physically meaningless. To be sure, I asked all 4 leading AI systems 2 questions about it. What does this paper prove? What does this mean for mankind? The unanimous conclusion: GMST is physically meaningless and the policy edifice built on it has no scientific basis. The emperor has no clothes, and even his own court's AI systems see it. Here's some of the details of those conversations I won't bore you with, but if you want them, catch up with me later. So now on to CMIP, the climate models. My 2025 paper notes that every CMIP model is tuned to reproduce meaningless GMST. These are coupled global circulation CMIP models, and they're tuned, calibrated, and validated against historical GMST trends. They include hundreds of adjustable tuning parameters and operate under unsolved Navier-Stokes equations. Those parameters are adjusted until the models reproduce the trajectory of meaningless GMST. They call that validation, and use those models to drive trillions, even hundreds of trillions in global energy policy if you look out to 2050. All the outputs from CMIP models are therefore equally meaningless, all variables, not just temperature. Okay, the Bern impulse response function, IRF models, govern IPCC estimates of how long CO2 will stay in the atmosphere. The three Bern versions are AR2, AR3 and 4 with an absurd 15% permanent fraction, AR5 and 6 with a ridiculous 22% permanent fraction. These IRFs are simplified multi-exponential models fit not to any measurements, but to the output of more complex models. So they're not normal models, they are models of models, or models of model ensembles, each of which was tuned to, wait for it, you guessed it, physically meaningless GMST. Using these, IPCC guarantees us CO2 will persist for hundreds, thousands, and even tens of thousands of years. But look at the dark blue, green, and orange curves there. These Bern curves don't even match each other, not even close. If the Bern models were representative of reality, then successive refinements would produce convergence, not chaos. More damning still, the scientists who created the Bern models warned us, quote, "The coefficients and timescales should not be interpreted literally as distinct physical processes or timescales," unquote. So what did the IPCC do? Exactly the opposite. AR5, box 6.1, even claimed to use data from Juice et al. 2013, a paper that has no data. Juice ran 3 complex models for about 100 years and a handful of much simpler models out to 1,000 years. None of these models has ever been validated or even shown to be remotely realistic over multi-century timescales. Yet the IPCC declared with high confidence that 15 to 40% of all the CO2 we emit between now and 2100 will remain in the atmosphere longer than 1,000 years. Okay, now my personal favorite from the circle of 5 lies, ocean heat content, or OHC. The official Argo map looks impressive, but it's cropped to hide the poles and it doesn't differentiate deep or upper floats. Here's the real picture from NOAA, showing every float that surfaced in the 12 days prior to March 25, a couple of weeks ago. Look at the poles, virtually nothing beyond 60 degrees. And the entire deep Argo fleet has 230 floats deployed to sample temperatures in the half of the ocean volume where literally half of its thermal energy resides below 2,000 meters. Here's how each of the 4,200 non-deep floats work. They descend to 1,000 meters, they drift for 9 days doing nothing, drop to 2,000 meters, ascend slowly to the surface over 6 to 10 hours, collecting about 1,000 temperature measurements, spend about 15 minutes at the surface to get a GPS time and location fix, and then transmit the measurements to a satellite, rinse and repeat for a few years until the battery dies. Now, to be fair, that's all valid data gathering, but that's also where reality ends. First, there is no subsurface positioning. Every measurement from the ascent is assigned to the one surface GPS time and location fix. Second, 12,000 profiles per month are extrapolated onto 45,000 grid cells using correlation scales up to 2,800 kilometers. Every single gridded value is calculated, not measured. And extrapolation does not increase information content, it decreases it. Third, the same invalid process constructs a reference climatology over an arbitrary 15-year baseline, adding another layer of invalid averaging. Then the anomalies are computed. This is what we like to call the ghost minus ghost trick. Fourth, a discrete sum over these calculated values, not an integral, multiplied by incorrectly assumed constant density and heat capacity. Fifth, EEI is then declared to be 0.7 plus or minus 0.2 watts per square meter, despite 60% of the ocean being totally unsampled and a true uncertainty easily exceeding plus or minus 1 watt per square meter. The actual result, EEI, is no different from 0 as measured by the IPCC. Even without the thermodynamic nullification, the following uncertainties annihilate any claimed OHC signal. Mesoscale variability is the biggest. Then you have deep ocean ignorance, sea level closure, the Eulerian-Lagrangian framework bias, I love that one, arbitrary baseline bias, and 2 other smaller ones. Compounded at 95% confidence, the total easily exceeds plus or minus 1 watt per meter square. The claimed signal of 0.7 is smaller than the noise. So now, a little historical digression. When Argo was designed in 1998, its objectives were ocean observation and weather forecasting, with no mention of global OHC or EEI. That idea was added a decade later during ClimateGate, when Kevin Trenberth emailed hockey stick Michael Mann and his entire climate science hockey team saying, quote, "We can't account for the lack of warming, and it's a travesty that we can't. The series data shows there should be even more warming, but the data are surely wrong. Our observing system is inadequate." From that moment, Argo was repurposed into a global energy accounting tool, and the NASA series satellite measurements were forced to match it. Our OHC paper, published 1 month ago, is ironically in total agreement with Trenberth's 2009 assessment. So we were very excited to see his nearly immediate response to our paper a few days ago. He says, "It's absolute nonsense. I don't want to waste my time on it." Clearly, we're over the target. Okay, back to Earth's energy imbalance. So here's what the IPCC did at AR6. The numbers in parens show their 90% confidence ranges. Using what NASA series has called a one-time global adjustment, they fudged their numbers to match the Argo-derived OHC estimate. Look, incoming solar is 340, but the range given is 340 to 341. Reflected solar is 100, while the range is 97 to 100. And outgoing long wave is 239 with the range 237 to 242. So the forced result is 340 minus 100 minus 239 equals 1. Wait a minute. But if you actually use the real numbers, you get something very different. EEI could actually be anything from -2 to +7, and that's definitely not 1. All right, and remember, NASA series is a direct measurement, while OHC is an invalid calculation. So in true Orwellian fashion, they're constraining the real measurements with an unreal calculation. So on the right here, you see the unadjusted NASA series satellite measurements. That's 4.3 plus or minus 8 at 95% confidence. That can't resolve the EEI signal, period. On the left, you have Argo-derived OHC claims, 0.7 plus or minus 0.2, but actual uncertainties are easily plus or minus 1 or more. The one-time global adjustment forces series to match Argo. The resulting agreement is then cited as independent confirmation. That's circular reasoning, not validation. Now let's close the loop with CO2. In every paleo record, Antarctic ice cores, Greenland, the entire 500 million year Phanerozoic record, temperature changes precede CO2 changes always, without exception. Even El Nino warming precedes CO2 spikes by 6 months, and we know the physics. Warmer water outgasses more CO2. IPCC's assumption that CO2 causes temperature increases, on the other hand, has never been observed in any paleo record on any time scale. Now, here's one of the most pivotal findings of modern climate science. Listen closely, because this one is going to be on the test. Here's what's called a Keeling plot of 4 stations spanning 40+ years by Koutsogiannis 2024. The legend shows the y-intercept for each station, which is the net isotopic signature of what was added to the atmosphere over the 40+ years. It averages -13.2 parts per thousand or per mil, and nobody has ever before applied this standard hydrology analysis to climate science until Koutsayanis did. Critically, this negative 13.2 intercept hasn't budged while CO2 emissions tripled. Using proxy data, Koutsayanis also extended it back 500 years to the Little Ice Age, and the 13.2 doesn't change. Why does this matter? Fossil fuels have a net signature of negative 28 per mil. If human emissions were adding to the atmosphere, as the IPCC assumes, the input signature would have to be noticeably declining from negative 13.2 toward negative 28, but it hasn't budged for 500 years. Natural CO2 fluxes in and out of the atmosphere are 20 times that of human emissions, by the way, and the man-made isotopic signal is totally undetectable. Therefore, the rising CO2 in the atmosphere is, listen closely now, not from human emissions, period. The input signature does, however, match temperature-driven ocean and soil outgassing. This is direct and total falsification of the IPCC's assumption that man-made CO2 is increasing in the atmosphere. This table extends Tom Siegelstad's compilation of 25 studies spanning decades, all showing short CO2 residence times of 5 to 10 years, and all ignored by the IPCC. Every paper claiming 1,000 plus year adjustment times traces back to one 1987 carbon model paper. That entire lineage rests on that one IRF model, which we demolished in our CO2 paper. By contrast, all the modern 4-year papers and even the older 5 to 15-year studies arrive at essentially the same answer using completely different methods. That's the hallmark of real scientific validity. Long adjustment times have never been supported by any empirical science. Back to our CO2 residence slide for a moment. The light blue curve is Koutsayanis' refined reservoir routing model fitted directly to raw Mauna Loa and Barrow, Alaska data with 99.7% explained variance and e-folding time of 4 years. Nuclear weapons testing between 1955 and 63 injected radioactive carbon-14 into the atmosphere, creating the ideal natural experiment. The purple curve is the single exponential perfect fit to the raw bomb carbon-14 data. The decay from 65 follows a pure single exponential with e-folding time of 17.2 years. Now look at the burn curves. They're not even close. By year 2020, the red line, the actual bomb carbon-14 is around 3 or 4% of its 1965 peak, where AR34 and AR56 burn models predict 55 and 42 respectively. That's not just slightly wrong, it's categorically, visually, mathematically at odds with reality. Total falsification. Now, let's circle back on the truth about the circle of 5. Number 1, GMST is physically meaningless. 2, CMIP models are tuned to GMST, inheriting total invalidity. 3, OHC is calculated through the same invalid temperature averaging process as GMST and also dominated by extrapolation. EEI uncertainty, number 4, is an order of magnitude larger than IPCC claims and relies on circular OHC adjustment. Purported EEI is then used as, quote, proof of human CO2 forcing. 5, rising CO2 is erroneously attributed to humans and claimed to drive GMST, closing the circle. The burn models falsified by bomb carbon-14 data and contradicted by isotopic evidence are used to assert long-term CO2 persistence. The IPCC calls all of this multiple lines of evidence. Math reminds us that 5 times 0 equals 0. And this table catalogs the damage. Every single IPCC climate metric, GMST, OHC, EEI, ECS, TCR, TCRE, the carbon budgets, and 10 others are physically meaningless, no exceptions, period. Not because the measurements are imprecise, but because the calculation methodologies themselves destroy any connection to physical reality through circular reasoning, invalid temperature averaging, or the falsified burn model. Column 3 lays out the specific failures for each. 4 shows how deeply AR6 depends on them. These aren't independent metrics. They're the same zeros repackaged over and over again. So It's a house of cards, the IPCC house of cards. We've just removed the foundation and everything collapses. The swindlers were patient. They took over the schools, they controlled the journals, they built an empire that lasted 38 years, but they made one mistake. They built it on a foundation checkable by anyone with a first-year thermo textbook. Math requires no authority, no consensus, and no grant money. Only the humility and courage to follow where the equations lead. Too many of us have been arguing if the emperor's robes are right for the weather. But the emperor has no clothes, he never did, and it's time for all of us to say so. Thank you.
Laptop back. Okay, everyone, thank you. We're gonna, oh my gosh, I'm so sorry. We are gonna have a microphone come around for questions. Please, again, direct your question towards an individual panel member. Don't give it to the whole panel because we're really trying to get as many questions as we can in. So let's start right here.
I've asked this question before at a previous conference, and I think the answer is no one knows. But the question is, for this global temperature that we've been reading about and everything is based on, which you now say is totally bogus, but is there any place where you can go where it will say, how is it measured? How do you go around the world and say, this segment is measured at this temperature station or using this data or whatever? Is there anything that outlines it? I think you said no. Is that correct?
No, what I'm saying, I'll answer both questions. What I'm saying is global temperature does not exist, number one, okay? So it's bupkis, the Yiddish word for nothing. There is no such thing as global temperature. Now, the thing then they say, but we're going to take an average of a bunch of temperatures. Averaging, though, just because you average temperatures doesn't mean it produces anything that relates to anything in the physical world. It does not. So if you want to know what numbers they average, I can tell you, but it doesn't matter. The result of that mathematical operation is not anything. It's literally nothing. It's not that it's inaccurate. It's not that it's approximate. It's not that it's an estimate. It's nothing. How they do it? Okay. They have, as Anthony was talking about, they got zillions of land-based weather stations. That's one source of data where they have thermometers taking temperatures. On the ocean, they've got buoys and they have floats and they have ships, and those are taking various sea surface temperatures. And they gather all that data together. They then grid it through a mathematical procedure. They average it using a surface area weighted average process. They also do lots of adjustments to that data before they even get into the averaging process. And they do averages of averages, by the way. So they don't actually take the actual measured temperatures at each station even. For example, at one station, the thermometers used to measure high and low of the day. Now the more modern ones are constantly sampling the temperature, but they still do a high and low, and they publish a Tmax and a Tmin. And for the GMST calculation, they take Tmax plus Tmin over 2, making it another abstraction that's totally meaningless. So it's meaningless at about 17 levels, but the most fundamental level that it's meaningless at is thermodynamics. It completely doesn't relate to anything real. Yeah.
I have a question, mostly for David Legates, but the other two may also have similar problems. I would assert that certainly for precipitation, okay, for global average precipitation, that NOAA hasn't the faintest idea what you have, because you showed thousands of rain gauges on the United States. Mm-hmm. You showed, okay, land is only 29% of the world. The oceans are 71% of the world. You showed no more than a dozen or so, a few dozens of rain gauges on the oceans. Okay. I have been raced across the ocean a dozen times, and I know a lot about how much precipitation there is in the ocean. It is enormous, especially, there's virtually nothing north of about plus or minus 25 degrees until you get it into the tropics. But then in the tropics, there are continuous squalls. And then when you get to the intertropical convergence zone, it's continuous downpour.
Yeah.
Very intense downpour. When you get below the ICCC, south of it, the squall rate is up by a factor of 5 to 10. These are enormous amount of precipitation that's going, and the Hawaiians call this liquid sunshine. And a lot of this gets recycled. Some of it gets to land, and that's how we get most of our rainfall on land is from the great cloud factory in the Pacific Ocean. So the bottom line is, I don't think anybody has the faintest idea of how much actual participation there is globally.
And when you get over the oceans,
The same thing is true with temperatures.
yeah, when you get over the ocean, I didn't talk about it in detail because we don't have time. But they use indirect techniques such as microwave, such as satellite, and so forth. All of those are somehow calibrated back to the rain gauges, which have problems. And they also use a variety of other techniques that come along that makes it very difficult to compare the apples over the ocean with the oranges over the land. And so it's putting together a global climatology, mixing and matching how it's done in different places is really a mess. And that was part of my dissertation. I just didn't have time to go into all that here.
It's also true on temperatures.
Oh, yeah.
We got another question here.
Very little ocean-based temperature measurements.
Yeah.
That's right. Very little. Especially half of the ocean lies below 2,000 meters, and half of the thermal energy lies below 2,000 meters, and we have virtually no sampling going on there.
Yeah.
It's
can we get to another question? I'm sorry, I have to
Okay.
cut you off.
all right. Yeah.
This is good.
Okay, I'm Francis Menton, Manhattan Contrarian. On the question of a global average temperature, I know that UAH puts out their satellite record, and I've actually, I'm onto this question of the intensive property, and so I've asked John Christie, how do you deal with this, or is your thing some kind of an average of temperatures? He says, no, we measure the bulk heat content of the atmosphere, so that should be a valid global measure. And my question to you is, would you agree that that's what they do and that is a valid global measure?
No, that's not what they do. They use radiation from MSU units on satellites, and they measure radiation coming out of oxygen atoms, and then they do an aggregation of that, which is again localized measurements. They take them every, it's gridded in the same way. It has the same fundamental thermodynamic problem. So it doesn't make anything any better. You cannot measure heat content by taking point measurements. It's not possible because you don't know where the heat is. The heat is flowing around. We have a constantly convecting, constantly driven system, constantly overturning. Energy is going into the ocean, out of the ocean, into the atmosphere, around, up, down, sideways, and there's massive gradients. So if I take a measurement here and a measurement here at a point, it tells me nothing. The measurement here and the measurement here doesn't tell, unless you could get down to the level where you put a thermometer perhaps 1 millimeter apart throughout the atmosphere and throughout the ocean, and then took it synoptically at the same instant in time, because remember, the energy's flowing constantly. So if you don't take it at exact same moment, you're not measuring the same energy. The energy you measure here goes over there. So no, it's not possible. It's just not possible.
I'm gonna get over here. Thank you.
Actually, they need to be about a kilometer apart, not a millimeter. But that's still 500 million of them.
Right, and that's still, yeah, hundreds of or thousands of times denser than they are now. But yeah, we could argue about that.
Yeah, hi, my question's for Jonathan.
Yep.
I'm Tom Harris from International Climate Science Coalition Canada. It strikes me that Essex et al.'s argument about there being no global mean temperature would apply to any area, including countries, for example. So when Canada says that the north of Canada, which is, 40% of our whole country, is warming and the temperature is increasing by 2.7 degrees per decade or whatever, it doesn't make any sense to me. And it suggests that they're comparing an imaginary number, in other words, an average temperature over a huge area, with the global average. Neither of them mean anything.
That's correct. Any sufficiently large region is the same as global, and it has the same problem. In other words, unless you're in a small enough area that the gradients are quite small over the whole area, it's literally totally meaningless. But yeah, so averaging across the United States, meaningless. Averaging across any large region, Canada, whatever, meaningless. Absolutely.
Can we get Chris, because he's been with his hand up for a while.
Thank you.
I actually learned something new. I didn't know about that change in methodology. So I thought that was really cool. Regarding Clausius-Klaproth, I have a slide in my keynote tomorrow night about that in relation to the Texas floods. And what a lot of people don't understand when they, especially these climate scientists, or as I call them, climastrologists, they don't understand with that equation. If they took a basic meteorology course, cloud physics or thermodynamics, they'd understand that, and I'm sure you understand this, obviously, that that equation doesn't show how much rain falls or at what rate. It's just saturation vapor pressure.
Correct, correct.
And so that's one of my points that I'm going to make. Another thing too, and I'm not sure if you're aware of this, John Christie sent me some data on this, some daily precipitation data that he's gone in and filled in. A lot of the daily records, like daily measurements, are missing in the early part of the record in the online forms. And that's because the algorithm that NOAA has when they digitize the paper weather records eliminates extreme values that are probably accurate. It doesn't like it. And a good example of this is in Kerrville, Texas. They had record rainfall in 1900. That was over the 2025 value, but they didn't have that in the digitized record. So I was wondering if you were aware of that issue.
Yeah, I mean, there's all sorts of problems with precipitation. I mean, part of the problem is we ran a network in Delaware, and you get a leaf that blocks the rain gauge. So the rain gauge gets zero value. Well, does that mean it didn't rain there, or does that mean your value was incorrect? And there's the famous one, the Holt, Missouri rainfall event is now believed to be one where there was a leaf that blocked the hole. It piled up water, and then somehow the leaf moved, and all this water came down in a really quick mount, and poof, there was your rainfall. Whether that's true or not now, nobody knows because nobody was standing there to watch it. But that's part of the problem with measuring mass is it's a very difficult process.
We've got a little bit. Let's go over here.
For Anthony Watts, and it's thank you. I'm just curious about these ghost stations that continue to report after they've been closed, and I'm wondering if you could just quickly elaborate on how that data is actually manufactured and who's doing it.
Yeah, well, it's pretty simple, really. They put a flag in the database. They have a tag, the letter E. Now, why they chose that, I don't know. But you can go through the database of all these stations and then look at these flags and see that that E is there. And it says that the station, I guess, is estimated. I think that's why they chose E. And then if you go out and look for the station at the GPS coordinates they provide, it's not there.
No.
I'm going to let Anthony has a question for David, I believe.
I was
and
just
then
wondering, David,
done.
if you have ever looked to see if NOAA is creating ghost rain stations.
I would assume they are. And the reason I was going to answer your question too, is that the reason they do that is for the interpolation algorithms. The algorithms assume that you've got all the stations all the time, And if one disappears, they've got to go back and do it differently. And so to keep that consistent, you just simply estimate the value. Now we got a complete record, and we can do the same interpolation algorithm with all the same points, even though we've just made up a data point to allow the interpolation to work. So if it's they're doing it with air temperature, I'm positive they're doing it with precip.
Well, basically what you're saying is that precipitation measurement is all wet.
It's all washed up, yes.
Yeah. Well, our time is officially up, but okay, you have to promise, Doctor. Oh yeah, that's a good one. Are the ghost stations still on the payroll?
Careful. Are they what?
Are the ghost stations still on the payroll?
Payroll? No, we just feed them some scraps from time to time. No.
Thank you so much, everyone. And I'm sorry if we couldn't get to your questions, but we ran out of time here. All right. I think we have
We have to clear out for
a couple minutes until the next.
the next section comes up.
Do you need a clicker? All right. I think everybody else is skipping.
Okay, so this is to go forward, that is to go back.
Maybe that's what happens. All right, are you guys all ready? Let's get this rig rolling. The sooner we start, the sooner we're done. Waiting for that D-Gen to sit down. Yep. Should we go? All right, are we ready to start? Ready. All right. Good afternoon. I'm Cameron Schulte. I'm the Director of Government Relations at the Heartland Institute. I'm going to be moderating today's panel, the most important upcoming battles. I don't usually get to hang out with the smart people, but today they let me, and I'm proud to moderate a panel consisting of these guys. We've got Steve Milloy, Willis Eschenbach, Angela Wheeler, and Jason Issac. So I will go ahead and introduce them and then let them, we're going to have a something of an organic conversation. They're going to give remarks, and then we're going to move through, kind of have a conversation, and then Q&A. So without further ado, let me introduce Jason Issac. So Jason Issac, and I don't have his bio memorized, I apologize. Jason Issac, the Honorable Jason Issac is the founder and CEO of the American Energy Institute and also the husband of State Representative Kerry Issac. Jason has appeared live on Fox News, Fox Business, CNN, and other national news shows, and his commentaries have been published in Fox Business, The Hill, The Washington Examiner, The Daily Caller, and other publications. Prior to starting the American Energy Institute, Jason, a fourth-generation native Texan, was elected 4 times as the state representative for Hays and Blanco counties in the Texas Hill Country. He served on the Energy Resources and Environmental Regulation Committees, among others. During his 8 years of service, he successfully passed legislation to reduce taxes, strengthen election integrity, improve public education, preserve Second Amendment rights, protect local groundwater, and protect private property rights. He was repeatedly honored for his commitment to limited government and proved to be an effective leader, excelling at both advocating and conservative principles and working across the aisle to find responsible solutions for the future of the Lone Star State. Next, we have Steve Milloy. Steve is a recognized leader in the fight against junk science with more than 25 years of accomplishment and experience. He is also a policy advisor and a member of the board of directors at the Heartland Institute. Credited with popularizing the term junk science, Milloy is the founder and publisher of junkscience.com. And from 2000 to 2009, he wrote the popular junk science column for foxnews.com. He is an expert on energy, environmental, and public health, public affairs consultant, author, TV, radio commentator, and public speaker. Milloy was trained in natural sciences, biostatistics, law, and securities regulation. He has also been an attorney for the U.S. Securities and Exchange Commission and a broker-dealer, and a registered securities principal investment fund manager, nonprofit executive, print web columnist on science and business issues, and coal company executive. Milloy's latest book is Scare Pollution, Why and How to Fix the EPA. Milloy served on the Trump EPA transition team. Willis Eschenbach, he's actually the most interesting of them because you're going to love this bio. Willis Eschenbach is a polymath, reformed cowboy with absolutely no relevant credentials.
However, he has researched and written extensively about the climate, and he has a half dozen peer-reviewed papers in the scientific journals, including a peer-reviewed brief communications arising in Nature magazine. Go figure. It actually says go figure right there. And lastly, we have Angela Wheeler. Let me turn to her page one moment. Angela is an executive leader with more than 20 years of experience in marketing, publications, multimedia production, and nonprofit management. As Vice President of Marketing and Multimedia at the CO2 Coalition since 2022, she directs digital outreach, social media strategy, video production, website management, podcast development, and production, which is Climate Debrief. These efforts promote open scientific inquiry into CO2's beneficial role in Earth's ecosystems and encourage discussion that challenges prevailing climate crisis narratives. So with that, I'll let Willis lead off and get our conversation going this afternoon. Thank you.
Let's see, I should probably have a magic device here and some kind of in any case, without that, let me go ahead. I'm going to talk about the constructal law a bit. The constructal law is the most recently discovered thermodynamic law, and it is about how flow systems that are far from equilibrium evolve. It states that flow systems that are far from equilibrium evolve to increase the flow and the access of the flow. So in terms of the Earth's climate, what does that mean? Dr. Bajan and Dr. Adrian Bajan developed a theory that the Earth's climate system, in a constructal sense, is evolving to increase the flow of energy from the hot area around the tropics and the equator to the cold area in the poles. So in this model, we have two areas, AH and AL, the hot area with temperatures TH and TL. And the basics of the model are, in the hot area, you have energy coming in and energy going out, and there's leftover. It moves to the cold area where it's added to the energy coming in and it goes out. So there's a constant flow of energy going from the tropics to the poles. How does that look in the real world? Well, these are the actual hot and cold areas of the real world. The orange areas are the areas that are exporting heat. The blue and green areas are the areas that are receiving heat. And in agreement with the constructal model, this shows that it's relatively symmetrical, that the areas of the cold are about the same size on the north and south poles. Now, in the model, there is a straight line across there because it's just a model. Now, be clear that this model has no oceans, has no mountains. It's just a simple sphere illuminated by constant sunlight. There are four unknowns calculated by this model: the average temperatures of the hot and cold zones, the area of the hot zone, and the power flow that's going from the hot zone to the cold zone. There are three tuned parameters: the conductance, which is how easily the flow goes, the power absorbed in the hot and cold zones. There are four governing equations. In the hot zone, you have power in minus power out is the flow Q. In the cold zone, you have power out minus cold zone power in. That's also Q. The conductance is a function of the difference of the temperatures, and there's a constructal constraint that the flow is maximized. There's 4 real-world inputs, the albedo and the greenhouse factors for the hot and cold zones. The greenhouse factor is what percentage of the radiation from the surface makes it out to space. The albedo, of course, is what percentage of the incoming solar energy is reflected back to space. This is a movie I made of how the hot and cold zones vary over time. The answer is hardly at all. Year by year, these are the differences. There's some differences on the west coast of the North and South America, but in general, especially over the land, it's pretty well established. And even over the ocean, it doesn't change a whole lot. This is rainfall as a proxy for thunderstorms in the tropics. This is one of the big differences between the real world and the model. In the model, the overturning is just driven by the temperature difference. But in the real world, we have this band of thunderstorms that's driving the air upward and towards the poles and carrying immense amounts of heat. So, how well does the model do? Well, this shows the calculated temperatures, not anomalies, but actual temperatures from this model. This is from the series satellite data, hot and cold temperatures, and the modeled hot and cold temperatures. You can see that around the year 2010, there are some slight differences, but at this scale, you can't see any difference at all. This to me is pretty amazing because it takes so few actual inputs and it does such a good job. Now, is it tuned? Yes, it's tuned, but only for the difference between the hot and cold zones. Given just the difference between the hot and cold zone temperatures, it calculates the actual absolute temperatures. This is a close-up of the top one there. You can see again that around 2010, it's slightly larger. But overall, the model does an excellent job of showing the changes in the hot zone temperature. This is the same thing for the cold zone temperature. In both the hot zone and the cold zone temperatures, the main difference between the model and reality is that the swings are larger in the model. And I ascribe this to the fact that the model assumes that all the swings are due to temperature swings, where in reality, that's not the case. Some of the swings are due to things like the atmospheric window, which lets some of the upward radiation just escape directly to space. So we have good agreement here. Now, this is the actual and modeled power flow. Those are quite different. Why is that? Well, the reason is that if we go back to this here, you can see that there are large areas, desert areas in Australia, in North Africa, and in the Gobi area, and the area of Saudi Arabia that are actually in the cold receiving area, but they're not in the model. Those areas are not in the model. So that gives us a fairly large difference in the absolute values of how much power flow there is. But when we go and look at the anomalies, that's what the model predicts. That to me is quite astounding. that such a simple model with so few inputs gives such a close answer to how much the power flow is. And to me, this is excellent confirmation that the constructal model, which says that the Earth's climate system is not just a pool table where you strike a ball and it goes somewhere. It is constantly evolving to maximize that energy flow. It responds to the changes. It's not an inanimate kind of thing. It is constantly modifying and evolving to respond to changes in the albedo and respond to changes in the greenhouse factor. This is the other thing that's predicted by the model, which is where the boundaries are for the hot zone. The series hot zone boundaries and the constructal model hot zone boundaries, again, they're slightly different because same reason. In the real world, there are areas which are in the hot zone in the model, but are in the cold zone in the real world. But once again, it does quite a workmanlike job of showing the changes in the area of the hot zone. And here is the predicted and actual hot and cold zones. The actual and the model hot zone. The model hot zone is shown by the dotted yellow lines, top and bottom. The real hot zone is the white and black lines. And they're quite good. To take this further, I took a look at what doubling the atmospheric CO2 might do. So I recalculated the greenhouse factor by simply adding 3.7 watts per meter squared from the putative doubling of CO2. The model calculated increase in temperature was 1.1 degrees C per doubling in both the hot and cold zones. It was slightly different, 1.06 versus 1.14 or something like that. So that's quite small. It's not the smallest, but it's extremely small, and that drawing is not correct. Those lines should be higher up. I'm not sure why they're not. But I say that that is a maximum climate sensitivity because all I varied is the greenhouse factor. I didn't vary the albedo. And of course the albedo, because this is a dynamic system, the albedo will be changing as well. These are the shortfalls of the model. Here are the boundaries of the hot zone and the average area error in the flow. I think that it's related to the stable Sahara, Arabia, China irregularity. Further challenges, find the reasons for the larger swings in the model temperatures and explore the monthly variations. Improve the model by including the sensible and latent heat loss in the atmospheric and absorption of incoming sunlight and the surface transmitted irradiance. A few comments on this. First, it makes perfect sense. Albedo regulates how much energy enters the system. The greenhouse factor regulates how much energy leaves the system. The balance between those two is what we would expect to regulate the temperature. And this model shows that actually that's what's happening. Second, it shows that the greenhouse effect, the greenhouse factor, is a real quantity that needs to be taken into account. It's not of the size where it's any kind of danger. Like I say, my calculation, simple calculation, shows that climate sensitivity near the bottom, and I think that the sensitivity is actually lower due to the response of the albedo. Next, I've long held that the thermostatic effect of the thunderstorms and other emergent phenomena is critical. This supports that because the albedo and the greenhouse factor, more than anything else, are factors of the clouds. The albedo, of course, is mostly changed by changes in the clouds, and the same is true about the greenhouse factor. So that is my presentation for today, and I would sum it up by saying that all of the current climate models are working in the wrong way. They assume that all possibilities are equally possible. They assume that the climate is some kind of fixed system where if you add a little here, everything has to change in a predictable manner. The system doesn't work that way. It works in a constructal method where the system is constantly evolving to maximize the throughput of energy. And until the climate models start dealing with that, we're going to have the same problems that we have with them, which is that they are basically tinker toy models that are used for political purposes. Thank you.
All right, next we have Angela Wheeler. I do want to point out that congratulations, you are the executive director of the CO2 Coalition, so congratulations on that. So next up, Angela Wheeler, thank you.
Yes, I was just about to point out that just as of the first of the month, I went from being the vice president of marketing and multimedia to the executive director, so I've had quite a week. And so, what I would like to speak with you about today is the state of science education in America and restoring the scientific method. I'm here to express the urgent need for a course correction in science education. American students are not being taught, they are being indoctrinated. That may sound harsh, but withhold judgment until you see the evidence. The traditional scientific method has been replaced with political slogans. Nearly all public school districts have replaced real science with junk science and are using fear to promote a political agenda. But there's a lot we can do. Today, we'll look at the evidence, expose the corruption, and I will lay out our strategy to take science education back. This is what some recent data tells us. The 2025 University of Chicago Energy Policy Institute poll showed that in 2017, 55% of people believed that climate change was man-caused. And by 2025, it was slightly down to 52%. A number to be very concerned about is the number of young Republicans who have bought into the climate crisis narrative. A demographic you would think would be more skeptical. That number is up from 26% in 2017, and now it's 42%. And if you're curious about other political affiliations, 67% of Democrats and 45% of independents believe that climate change is man-caused. There are some things we can infer from this. Most importantly, our education system is negatively influencing students. Public science education has replaced critical thinking with emotion, and emotion based on false data. We must equip the next generation with the tools to think critically and eliminate classroom indoctrination. One of the places where we specifically see a problem is with next generation science standards. And what those standards do is weakened critical thinking. 13 years ago, next generation science standards were introduced and have been adopted in 49 states. These standards didn't just tweak the curriculum, they gutted the heart of science. The traditional scientific method, observe, question, hypothesize, predict, experiment, analyze, repeat, has been replaced by vague science and engineering practices. What does this mean? Political agendas, climate alarmism, bias, consensus over evidence, models and groupthink promoted as gospel, politicized science instead of objective empirical analysis. And the result? No measurable improvement in US science performance. American students are falling behind the world in science education while being fed propaganda. This is not education. This is indoctrination. And this is a significant reason for all of us to be concerned. I should note that our CO2 Coalition member, John Droz, fought hard in North Carolina to get the traditional scientific method reinstated, and he won. And we need to duplicate his efforts in other states. How did science education become politicized? Among the challenges and paradoxes is the National Science Teaching Association, NSTA, the very group that sets the tone for science teachers across America, is saturated with climate activism. Their website promotes titles like Climate Change Education, a model of justice-oriented STEM. The Green Room, when climate change causes extinction. And 1.5 degrees Celsius may not seem like much, but it's a really big deal. They literally tell teachers to listen with compassion and authentic curiosity so children can open up and further explore their feelings. Not data, not experiments, explore their feelings. And the image on the slide says it all. A student standing in front of a whiteboard that reads, "There is no planet B." That is emotional manipulation in the public school systems that students face every day. Emphasis on the word public because we're funding that. This is not science. This is activism disguised as education. So the CO2 Coalition called them out on this. We published a detailed challenge to the NSTA's official position statement on climate change. They claim Earth's climate is changing largely due to human-induced increases in heat-absorbing greenhouse gases, that there is an overwhelming scientific consensus with increasing certainty, and that this should be taught as settled science, awarding it a position in science that we don't even give to gravity. We looked at their evidence, listed their flaws, and invited them to debate us. Show us the empirical evidence. Show us the falsifiable tests. Because as we all know, science does not advance by consensus. It advances by rigorous testing and observation. Our publication, challenging the NSTA's position on climate change, is public and available at co2coalition.org. The NSTA's position shows us that the shift from inquiry to indoctrination is happening right now in classrooms across America. Now it gets fun. In March 2023, we confronted the NSTA. At their own conference in Atlanta, we thought if they were really instructors of science, they would welcome a debate. The CO2 Coalition paid for a booth. And as you can see here, Dr. Sharon Camp, Dr. Rafaela Nascimento, Gregory Wrightstone, and I brought educational resources and scientific evidence challenging their consensus. Many teachers were very interested in our data and aware that there was an alternative viewpoint. They thought it all been settled. And we were visited by some other exhibitors, groups like NOAA, a government organization, accusing us of being funded by big oil. We distributed hundreds of books and publications. Then the beginning of day 2, we were approached by the NSTA bosses, and they had security in tow. Either stop passing out this heresy or leave. We were kicked out for daring to offer a different perspective. The largest science teachers organization in the country physically removed scientists from their convention because we challenged the dogma. This is not how science works. This is how cults protect their narrative. But we succeeded anyway. Many teachers thanked us before the doors closed behind us. This is good too. While we were at the NSTA conference, we discovered the strangest of ironies. The NSTA proudly accepts money from Shell USA, that's Shell Oil Company, for their Shell Science Teaching Award. The people accusing us of being on the take from big oil are taking money from big oil. They are promoting the very industry they claim is destroying the planet. I assume Shell thought they were buying protection. So the NSTA takes the check, smiles for the photo, and then turns around and tells their teachers and students, don't do business with those people, they're evil. And Shell keeps giving them money. This is cynical opportunism. They demonize the very industry that funds their awards while demanding that teachers accept that CO2 is poison. When politicians use the words scientific consensus to impose their will on us, it's not right, but it's one thing. They like the power and they're clearly ignorant of science, but we expect more from educators. Jonathan Osborne, Professor Emeritus of Education at Stanford, actually said, the goal of science is the achievement of consensus, not discovery, not truth, consensus. What's missing from his vision? Learning the scientific method, designing experiments, analyzing data, critical thinking. Consensus is a notion that is needed to sell an idea created in computer models that would never pass scientific muster. William Happer, Princeton Professor Emeritus, our CO2 Coalition founder and chairman, and a living legend in the world of physics, said it best, quote, observations anchor our understanding and weed out the theories that do not work. This has been the scientific method for more than 300 years. Computer models are not meant to replace theory and observation and to serve as an authority of their own, unquote. And that's the real difference in what our scientific data shows on climate change and what their computer models find. They are seeking an answer they want. And the only way they can get there is through consensus and computer models. Look at the difference makers who changed the world through rigorous science. William Happer invented the sodium guide star laser, giving us sharp views of distant worlds from the ground that revolutionized astronomy. John Clauser performed rigorous experiments that confirmed quantum entanglement, challenging prevailing assumptions and earning the Nobel Prize. Galileo used his telescope to let observation triumph over dogma. Marie Curie, working in a makeshift lab under dangerous conditions, persisted with painstaking experiments to discover radium and polonium forever changing physics and medicine. And Louis Pasteur's meticulous work disproved spontaneous generation and gave us vaccines that saved millions of lives. This is what happens when brilliant minds follow the scientific method with courage and rigor. They expand humanity's understanding and improve lives. That's the kind of science we should be teaching across classrooms in America. Consensus can be used to manipulate. The political need for a crisis has created a dangerous narrative, and it's taking its toll on young people. Students have been taught to be terrified of what is to come, and they believe it is out of their control. Annika Sweetland, a climate studies graduate, lay awake night after night in worry. She calculated when food shortages would hit. She worried about where she could safely live because of rising sea level. She even questioned whether it was ethical to bring a child into a world she believed was collapsing. In one interview, I heard Annika say, "All they had done was teach me. No threats, no violence, just teaching." Annika is from Australia, but that crisis narrative is being sold to students in America every day. One of those American students, Lucy Biggers, had a similar experience. She mentioned in an interview that she got her identity from being a good person. She believed that good people don't question the climate movement. Good people don't listen to fossil fuel shills or defend fossil fuels. Good people don't question the climate narrative. But now the good news is that both Lucy and Annika awakened to the fact that they had been misled. They are examples of climate activists who shut off the alarm. And they are both sharing their experiences at this conference. Annika Sweetland is now a member of the CO2 Coalition and will be working together with our incredible team to defeat the forces of disinformation that have wreaked havoc on science education. We at the CO2 Coalition are breaking up the climate junkies' monopoly on science education. We created the CO2 Learning Center to reach even the youngest students. Right now, we are mostly K through 8th grade focused, but we are working on adding high school and college materials. Our distinguished volunteer scientists have written books that teach the truth about carbon dioxide, making it understandable and relatable to children. Throughout our materials, children learn that CO2 is the miracle molecule that makes life possible, not a pollutant to fear. Our books are beautifully illustrated by our visual arts director, Tiago Hellinger. Tiago also illustrates and animates our videos that are written by our Education Committee Chairman, Payne Kilborn. And each book and video have comprehensive lesson plans written by Dr. Sharon Camp, our Senior Education Advisor. In addition to the NSTA conference, for the last 3 years, we've attended many homeschool conferences, distributing our books and lesson plans to parent educators who are desperate to teach their children real critical thinking skills. We also distribute our science materials to private schools and public schools willing to teach real science, all paid for by our donors. We are about to launch a scholarship program that will provide financial support for young scientists seeking answers. These real science-focused students will lead the descent to the climate crisis narrative, sharing the data and science that shares what students so greatly need to see, that there is no climate crisis. We will also be working with schools to start science clubs and will sponsor our members to speak at schools, sponsoring debates for anyone willing to defend their junk science. The more influence we have over public discourse, the more people will realize that there is another side to this narrative that is based in logic and real science, not computer models or consensus. Our education committee is comprised of members with impressive science credentials, volunteering their time and expertise with nothing to gain but the hope of a future where students can learn science without an agenda attached. The battle for science education is the battle for our children's future. We cannot let fear replace facts. We cannot let consensus replace the scientific method. We must restore curiosity, rigor, and wonder to every classroom. I'm looking forward to working with all of you to restore the highest standards of science education.
Okay, well, good afternoon, everybody. Let's see if this works. It's not working yet. Let's go back. Okay. All right. I'm Steve Milloy. It's great to be here. This is my second presentation of the day. There are two things that are important to me in my professional line of work, science reality and making it stick. And I'm concerned that that's not happening. I was a member of the EPA transition team for the first Trump administration, and I was in charge of writing the plan for fixing science at EPA. And so I did a comprehensive plan, and a lot of it was done. But then as soon as Biden became president, it became undone. And so I don't want that to happen again. I want things to stick. It's very important that they stick. Because if they don't stick, then as soon as there is the next Democrat president, which could happen in a couple of years, we're going to be right back to where we were with Obama and Biden. And so at this point, we have about 33 months left to go. And this panel is about major upcoming battles. I'm going to tell you what I think they are from my perspective, which is science and making it stick. Science realism, making it stick. So the first thing I want to talk about is Massachusetts versus EPA. Now, the endangerment finding was issued by the Obama administration in 2009. It's the key federal finding underlying all of federal climate activity. And it is that emissions of greenhouse gases threaten public health and welfare. And so, it's fantastic that the Trump administration has now rescinded the endangerment finding that the Obama administration issued, but that's not enough. And, kudos go to Lee Zeldin for doing this. This morning, Craig Rucker described Zeldin as the greatest EPA administrator ever, and that is certainly true. But I'm also going to tell you that that's a pretty low bar. Okay? I mean, we've had many Democrat EPA administrators, and they've been awful. We've had Republican administrators who have been awful. The best Republican administrators have been only okay in that they, did not advance the regulatory agenda too much. Now, when it comes to the endangerment finding, the key issue is the Supreme Court case in 2007, Massachusetts versus EPA. This case was wrongly decided. It was as wrongly decided as Roe versus Wade, just making things up. The key finding was that, the Clean Air Act, which provides EPA with its authority to regulate air quality, air pollution, air pollutants, does not mention greenhouse gases at all, as far as EPA regulation of them. And so through hook and crook. I don't want to go through the whole process, but the Clinton administration basically set up the Bush administration to fall into the trap of Massachusetts versus EPA winding up at the Supreme Court. And this case came up right after Al Gore's movie came out, and there was, climate hysteria. 2007, that's about the time of the first Heartland climate conference. And the court ruled that EPA could, not that it had to, but could regulate greenhouse gases. Okay. And of course, when the Obama administration came to town, that's what they did. and they were so organized, they had their minds made up before Inauguration Day what they were going to do. And within 9 months, they timed their announcement for the endangerment finding for the Copenhagen conference in 2009. And so since then, they've been regulating greenhouse gases and issuing other endangerment findings for, stationary sources and such. And so, and groups like Heartland, CO2 Coalition, Competitive Enterprise Institute over the years and others have petitioned EPA to rescind the endangerment finding based on science, and EPA never did anything about it. Even in Trump 1, they did not dare propose to rescind the endangerment finding. So, of course, President Trump ordered it done by executive order very early, fantastic. And Zeldin got around to doing it in February. Now, President Trump only has 33 months to go, and this is very important. So the finding was recently rescinded. The environmentalists sued about a week later, and so there's going to be a case heard now in the DC Circuit, and maybe it'll get to the Supreme Court. I'm personally surprised that the environmentalists filed this lawsuit, because the smartest thing for them, I think, would have been just to, let EPA rescind the endangerment finding, so that when Democrats, they obviously are going to be very positive about thinking Democrats can be elected in 2028, so that when we get a Democrat administration, they don't have to worry about getting Congress to do anything on climate, because they'll just reissue the endangerment finding and we could just go back to where we were. So there's this ongoing litigation now, and it's really a race against time. And we have wasted time. President Trump in last April, issued an executive order saying that regulations that were made illegal by Supreme Court decisions, they could be summarily eliminated without public comment. At the time when I saw that, I thought, wow, that's great, because that's what's going to happen to the endangerment finding. If you went to lunch, you heard Patrick Morrissey talk about West Virginia versus EPA, where EPA needs express congressional authorization to undertake major regulatory programs. And of course, climate is a major regulatory program. And so it's quite obvious that West Virginia versus EPA, in effect, overturns Massachusetts versus EPA. Now, the reason it's not explicitly like that is because, when the red states, led by Patrick, sued, none of them asked for that. None of them asked for Massachusetts versus EPA to be overturned. And with the conservative Supreme Court, if you don't ask for it, they're not going to do it on their own. So you have to ask for it. And if EPA had just deleted the endangerment finding last spring, the environmentalists probably would have sued, but the case would have quickly made it to the Supreme Court on the issue of whether the Trump administration could delete an illegal regulation. And the issue would be, is the endangerment finding illegal under West Virginia versus EPA? And, we could have hashed it out, but that didn't happen. We had this abortive effort at the Climate Working Group over the summer that gave time for the National Academy of Sciences to get involved and do their work. And then shortly there was, a lawsuit about that report, and things have just really gotten messed up. And I want to get this fixed. We can fix this now. And so the green strategy here is to run out the clock. to drag out the litigation, and hope for regime change, starting with the midterms, and make things chaotic and unknowable. You know, and if there's anything we've learned from today's world, you cannot predict what's going to happen tomorrow, and it could have significant impacts. You know, I don't think the world used to be this way, or at least it wasn't during the 90s and 2000s, but it is now. We just don't know what's going to happen, and so we need to get these things done. And so it's very important that we get this endangerment finding case out of the DC Circuit to the Supreme Court so that they can overturn Massachusetts versus EPA. It is not enough for the Supreme Court to rule that the Trump administration could rescind the endangerment finding. And the reason for that is because when we get a Democrat administration, they'll just reissue it. We need to get it to the point where this Massachusetts versus EPA case is no longer considered good law. It either needs to be explicitly overturned, or there must be some workaround where it's just not good law. No one can rely on it anymore, because you know, we can't stop Congress from considering climate because of, you know, the nature of our government, but that's fine. You know, let the environmentalists try to get climate through Congress. Okay, that'll be a very difficult task, and that's where we need to go. So, and towards this end, you know, groups like the CO2 Coalition, Competitive Enterprise Institute, Texas Public Policy Foundation, I think Pacific Legal Foundation as well, maybe, are intervening in the case, in the litigation, the endangerment finding litigation, as parties. And as parties, they hope to be able to steer the litigation. You know, if you just leave the litigation to red states, well, you're going to get the kind of result in West Virginia versus EPA, where they forgot to ask to overturn Massachusetts versus EPA. Okay, and that was a major mistake. If you just leave it to the Trump administration and the Department of Justice lawyers, well, we've all seen what kind of lawyering they have. It's not very good. It's not consistent. It's not very good. I don't know what will happen. So we have think tanks have gotten, you know, good lawyers, and I hope that, you know, we can shape the litigation that way. So this is a very important battle. We need to get this done. We need to get it done while President Trump is in office, and we must get rid of Massachusetts versus EPA. Okay, the next thing is science. And this is not climate science per se. I'm just talking about all of the science that EPA does. This actually does have kind of a link to the climate working group that DOE tried to put together. So I started working on these issues in 1990. I worked for a regulatory lobbyist. He hired me because I was a lawyer and a statistician, and there was this whole burgeoning field of EPA risk assessment. So I got involved in that. And I did that for a while, and then eventually I got a contract from the Department of Energy because they were being persecuted by EPA on nuclear waste and nuclear cleanup. And the Department of Energy wanted a report showing how, you know, when EPA risk management decisions are based on politics, not science. So, you know, the good news was EPA doesn't use science. EPA uses what we call science policy. And science policy, as an example, and we'll talk about this a little later, the linear no threshold model for cancer risk assessment. I've got graphs to show you. And it's basically where, you know, because people who are exposed to radiation, they have a, you know, higher risk of cancer at very high doses. And we don't have any data showing that they get cancer or have an increased cancer risk at lower doses. EPA just draws a line from where people have an increased risk down to zero, so that any exposure to radiation increases cancer risk. Or another science policy is, you know, if you can poison mice with some chemical and cause them to have an increase in cancer, we'll just assume that the same thing happens in humans. It's not science, it's an assumption. And that's what science policy is, and there's a bunch of these. So that's what my report was all about. It was all about science policy. And, you know, science policy, these assumptions, they're sort of the precautionary principle writ large. They kind of made sense maybe in the 1970s, maybe in the 1980s, because we didn't really know a lot about the effect of chemicals in the environment. Just no one had paid attention to it. We were too busy industrializing. And in the 70s and 80s, when Congress issued these laws where EPA had all this regulatory authority, there was no science to back it up. So the only way EPA could regulate was to make things up. Like if mice get cancer, then we'll just assume that humans get cancer. If people get cancer at very high exposures, we'll just assume that any exposure will cause cancer. So back then, it was acceptable, I think, and even maybe made sense to use the science policy, all these assumptions. But of course, 50 years later, we have lots of real world experience now with radiation, chemicals, and we don't need the science policy anymore. But of course, at EPA, they still use it. The Biden administration was still using the linear no threshold model to overregulate chemicals. Okay, so since you can't make EPA staff do science unless you fire everybody and hired a bunch of kids in high school that you could teach them what science was, because I mean you can't hire kids that have graduated from today's universities. They don't know anything about science either. So since you can't do that, my solution, and from the beginning in my report, the solution is just to admit what you know and what you don't know. Okay, I mean, I can understand, we don't know whether this causes cancer, but, we're worried, so we're going to regulate. I can understand that. That's acceptable. Where the problem, though, is that EPA uses these assumptions and they pretend that it's science. Okay, so they scare the bejeebers out of people when there's no scientific basis for it. Okay, another thing needs to be fixed at EPA is the fraud. There's just an incredible amount of science fraud going on. My most recent book, Scare Pollution, Why and How to Fix the EPA, describes the case of particulate matter. Now, before the Clinton administration, no one thought that particulate matter in the air was a problem. Fine particulate matter, it's like soot and dust, 1/20th the width of a human hair. It's very small. If you have a walk-in closet, you should get like an air cleaner that has a PM 2.5 reader, and you'll see what I'm talking about. EPA says that one particle exposure to inhalation of one particle of dust, which is unavoidable. There's PM 2.5 floating around this room right now. Inhalation of one particle could kill you now or in 80 years. Okay, it's like a magic particle. It's the most toxic substance known to man. There's no substance on Earth as toxic as particulate matter, at least the way EPA has described it. Now, and when I'm talking about the fraud, so there was all this epidemiology, study of human population, disease in human populations that EPA had done and considered, and it had never been considered to be a problem. There was certainly no link between PM 2.5 and death. But the Clinton administration came in, and all of a sudden they said, you know what, PM 2.5 causes death. Even though their scientists, their independent scientific advisory board said, no, EPA, that's wrong. But EPA said, well, we have all this epidemiology, which was basically zero correlation stuff. But EPA converted that somehow magically into evidence that particulate matter killed. Now, EPA knew deep down, that their evidence was not evidence. So the way they tried to confirm their lousy epidemiology was by doing human experiments. And what you see here is a picture of the truck, and below is a picture of a gas chamber. This is happening at the University of North Carolina School of Medicine. EPA idled the truck, piped the exhaust from the truck, and they would take out the carbon monoxide, but they would pipe the exhaust into that gas chamber. And into these gas chambers, they would put elderly people, they would put asthmatics, they would put elderly asthmatics, elderly people with heart disease, kidney disease. There are experiments in Los Angeles where they would spray diesel exhaust up the noses of children as young as 10. Okay. Now this sounds horrible, right? Because EPA says that any level of particulate matter can kill you. PM 2.5 is the most toxic substance known to man. Of course, there was not a cough or wheeze or anything that happened. Now, David Schneer, I don't know if he is here. He and I, when my group, Energy Environment Legal, was called American Traditions Institute, we sued EPA over these experiments. And we lost in court because the judge said, well, you guys don't have standing, which of course is the old trick to get conservatives to end litigation by conservatives. You don't have standing. The judge said, well, you would have to be one of the victims, one of the human guinea pigs. But of course, EPA didn't tell the victims that, the guinea pigs, that they thought PM 2.5 was the most dangerous substance known to man and these experiments might kill them. They told them that, this is just like regular air. The worst thing that can happen is maybe a cough or a wheeze. Of course, that was fraud. And then, getting the results, once again, in all the, thousands of people that underwent these experiments for money, so EPA was paying people to risk their lives, right? Not a cough or a wheeze. But none of those experimental results ever made it into an EPA rulemaking. And PM 2.5 turned out to be the most potent regulatory weapon EPA has ever had. Not only did it destroy half the coal industry in the 2010s, it was also the basis for a clean power plant. It's a flagship climate regulation. EPA could not calculate benefits for the Clean Power Plan. So what they did was they pretended that the Clean Power Plan, because it would reduce coal plant emissions, the emissions reduced would also include PM 2.5, and there would be, so many tens of thousands of people who didn't die prematurely because there would be less exposure to PM 2.5. So that's the kind, and this is sort of complex fraud. Right? Most people don't get this. We got this. We forced this case to the National Academy of Sciences for them to review it, but of course they rigged the review. It was very difficult to explain this to Congress. We couldn't get Congress interested, and because conservatives, Republicans, not really interested in science to start with, it was really easy for EPA to dance around it. But it was just pure fraud. I mentioned the linear non-threshold model for cancer risk assessment. This is it. And it's because of this model that we don't build, it's too expensive to build new nuclear reactors, and it's too expensive to permanently store nuclear waste. Now, this model was created by the National Academy of Sciences in the 1950s. It was adopted by EPA almost as soon as EPA was formed in 1970. And it's how radiation is regulated, nuclear plants or nuclear cleanup is regulated. And the graph is really pretty simple. The only data we have showing that radiation causes cancer is from very high exposures, like the atomic bomb data. There are some other medical exposures where people were exposed to very high levels, and all the data shows the same thing. So we have this situation where we only have very high exposure data, and we know that they have a higher risk. But then what EPA does is just draw a line from where the exposure risk is down to zero. And then any exposure greater than zero increases cancer risk. And of course, in EPA land, that is verboten. Okay, we can't have any of that. Now, the data, all the radiation data, the high exposure radiation data, the medical data, and the atomic bomb survivor data, okay, is very important. Even the atomic bomb survivor data show this. There's a certain amount of exposure to radiation that it doesn't increase your cancer risk. In fact, it reduces it. It's an effect called hormesis, and it's actually how vaccines work. You get a low dose, and it stimulates your immune system. And it's like that with radiation and chemicals as well. And so this is what the data, this J curve, is what the scientific data show. That you go from 0 to, reduced risk, and then you get to a high enough dose and it starts going up linearly. Okay, that's what our data shows. And that's how EPA regulates now. I'm sorry, they don't regulate that. They use the linear model, even though there's no data. For what we have data, it should be the J curve, but they don't want to do that. And of course, you can kind of understand why that would be a hard sell to the public. There's a certain amount of radiation that's okay. That's going to be a hard thing to sell. Even though you can demonstrate this in human populations, in populations where we know what the radiation exposures were. And the nuclear industry doesn't want to talk about this. EPA doesn't want to talk about this. There are, health physicists, the people that are responsible for regulating or for implementing radiation rules. They'll talk about it, but nobody in the radiation regulatory mafia will talk about it. But there is a compromise solution. You could just say that from 0 to a certain level, there's no increase in risk. This is called a threshold model. And then after the certain level, then the risk goes up. And if you were to use this sort of compromise, it would be a lot easier to store nuclear waste. It would be a lot easier, it'd be a lot cheaper to build nuclear power plants. So once again, this is an area where the Trump administration, President Trump issued an executive order ordering the Nuclear Regulatory Commission to fix this. Of course, he should have ordered EPA to fix it because EPA is the real problem. But of course, they never ask for help, so they don't really know what to do always. Nonetheless, there's been no progress made on this. They have not moved to change this model yet in any official way. And it's really interesting because I remember reading in the Washington Post a few months ago on the front page, there were all these groups that want to invest in nuclear power. Some of them have billion-dollar valuations already. But if they don't fix this model, that's just all going away. We're not going to see more nuclear power plants. The Greens oppose this. The Greens like maximum regulatory authority. You get that from the linear no threshold model. And this applies to chemicals as well. Okay, and the third thing I want to talk about is MAHA. And I know this might not be politically correct for the Trump administration, but it's a problem. And, I thought it was a problem when they were food nannying, okay? I have a libertarian background, bent. We don't need the government telling us what to eat, mostly because the government doesn't know what it's doing itself. I mean, how much bad information have we gotten from the government? The food pyramid was nonsense. They were wrong about cholesterol, wrong about low-fat diets. They're wrong about everything, okay? Because it's not based on science. It's based on, other considerations. So we don't need government food nannying. We don't need junk science food nannying. I'm going to tie this back to climate. Don't worry. And so, some of the MAHA scares, processed foods, food additives, pesticides, microplastics, forever chemicals. Just last week, it was microplastics. Okay, you remember last year, this study came out reporting that in autopsies, people were found to have 2 plastic spoons worth of microplastics in their brains. People remember that? Okay. Well, I looked at that, and you could see right away that it wasn't true. They weren't looking at microplastic. They were looking at something else because they had brains of like a 5-year-old and a 75-year-old. And the theory is that microplastics accumulate in your brains over time. But the 5-year-old and the 75-year-old had the same amount of microplastic in their brain, so which is not physically possible, per that theory. So they're literally just, making it up. They weren't looking, and as it turns out, fat produces false positives for plastic. So, and the brain is 60% fat. But none of this made any of the news coverage. And last week, RFK Jr. and even Administrator Zeldin, unfortunately, announced this program of microplastics. And, so, and because they're being pressured by MAHA, they're being pressured by MAHA, MAHA activists on, to get rid of pesticides. They focused on glyphosate, Roundup. We get rid of Roundup, our food supply is going to be in danger. They want to get rid of food additives. I know people are scared about food additives, but it's really unnecessary. And if we get rid of, processed foods, they call them ultra-processed foods. and food additives and pesticides, our food supply is going to be in a world of hurt. Okay, and it's going to hurt people, poor people, the most. And I think that Maha is actually a left-wing op, which should not surprise anybody, because RFK Jr., he's a left-winger. Okay, I know that Trump likes him, but he's a left-winger. Is Marc Morano here? Marc Morano did a bang-up interview of RFK Jr. in like 2014, where he says that he's for jailing CEOs and punishing climate skeptics. His sentence was 3 hots on a cot in The Hague with the other war criminals. That's you guys, me. Maybe not Jason Issac, but okay. These guys, Maha, they tried to get Zeldin fired because Zeldin would not, get rid of glyphosate. And there's some other pesticides at issue. They went after him. Now, what kind of Republicans go after a Republican administrator? It's crazy. And so they have him, they kind of have him, and I guess maybe to throw a bone to them, he signed up for the microplastic scare, okay? And it's crazy. We need to get rid of these people. These people are, and it's only a matter of time before they become interested in climate. The microplastics scare is actually a climate op, right? It's another way to get to the fossil fuel industry, to get to the oil and gas industry, because that's where plastic comes from, right? The petrochemical industry. So, I think I saw there's an op-ed in The Hill today by some Maha activists and a Democrat congressman, okay? This is a Democrat op. It's junk science fueled. They're going to turn on Trump because he's not going to do things fast enough. Pesticides. This is a major problem. The op-ed in The Hill today is about glyphosate. Okay, we need glyphosate. It's safe. It's inert. Microplastics, safe and inert. Your body just microplastics are everywhere in the air. We inhale them. We ingest them. They're in the air, food and water, everywhere. But they're inert. Okay, that's why plastic is so useful, right? Plastic it's inert, and our body excretes them. Okay, and the same with PFAS, forever chemicals. They're so useful. We've been using them for 80 years. They're so useful because they're inert. You can store stuff in them. They provide frictionless, have frictionless properties, and but it's something that Maha is after, and it's going to get to climate. I'm surprised it didn't stop. I guess getting Maha involved in climate is perhaps a leap too far now, but they will come back. They will get around to it, or they will get around. They will succeed with microplastics, or they're going to cause problems. They are not science-based, and science is what I care about. It is very disheartening to me. I've been in the conservative movement since 1990, and I've worked on science, obviously. And conservatives were always very level-headed people. People on my side, always very level-headed. They understood what risk assessment was. If you could explain it to them, they could understand what it's all about. They could understand the flaws of the EPA. Everybody was for regulatory reform. But now all of a sudden with Maha, this has changed. And we've got all these people that are worried about everything in the environment. They used to be confined to the Democrat Party and to radical environmental groups. Now it's a feature of the Trump administration. So, so that's my presentation. And so these are the things I'm worried about. I'm worried about the endangerment finding. We got to finish that. And even if we do get Massachusetts versus EPA overturned, the left is not going away. Just so you know, on climate, we may be winning now, but the long term, the left is not going away on any of this. They're going to come back. They have had far too much success with it to just walk away. Is Al Gore going to walk away from this? No, I just don't see that happening. And we need to fix the science. We at least need to get to the point where we can explain what the science, what the limitations of EPA risk decisions are, the uncertainties, and then we need to get rid of MAHA. So with that, I'll end. Thank you.
What's that? All right, lastly, we have Jason Issac, and then after he presents, we'll move to some questions. I'll kind of tee the conversation and then open up the room for other questions. Here you go, Jason.
Thanks, Cameron. Appreciate it. I don't know about you, but I could go for an afternoon coffee right about now. There was supposed to be coffee in all the rooms, but I understand one of the sponsors had some financial difficulties, and maybe Greenpeace will join us next year and they'll pay for the coffee. Who knows? We shall see. But the $345 million forced payment, isn't that great? I love it, especially to a Texas company. Greenpeace has got to pay Energy Transfer $345 million for the protests in 2016. I think that's a huge victory worth celebrating. I know we're supposed to be talking about the most important upcoming battles, but first, let me introduce myself. I'm Jason Issac, and I live a high carbon lifestyle. And I think the rest of the world should too. It's truly where you have economic prosperity and environmental leadership. And it was when I used that introduction, when I was testifying in front of Congress, I'm sitting there wedged between Stephen Moore and Mandy Gunasekara, two brilliant people that have just done incredible work for decades. And here I am, a guy who literally started cleaning up after animals as his first job at 12 years old, and then felt compelled to run for office a few decades later to do the same thing. The mess was very similar, but I introduced myself that way, and Congressman Raskin referred to me as a carbon king. And I'm like, I love it. I sat there for 4 hours of this congressional hearing, and I had written down notes, 2 words, carbon king. And I'm like, I've been anointed by a Democrat. So like the protest last weekend didn't apply to me. I'm not going to jail in The Hague because I just pardoned myself. And I'm not taking money from big oil. It's more like moderate, medium-sized little oil. I mean, I'm a trade organization that represents American energy companies, primarily oil, gas, coal, and nuclear. I mean, those things that actually work and are dense forms of energy. But talking about dense forms of energy that actually work, I think some of our biggest challenges coming up and the biggest battles that we have to look forward to are the grid. I mean, you look at what's happened in Germany, the deindustrialization that we're seeing in Germany. The largest manufacturer of Mercedes isn't in Germany, it's in South Carolina. I mean, maybe it's BMW, sorry, yeah, BMW. Mercedes is now shutting down operations in Germany. That announcement came out a couple of weeks ago. BASF, world-leading chemical manufacturing company with actually a big footprint in the panhandle of Texas, shutting down operations in Germany, citing high energy costs. You look at what's happened in Texas, where I'm from. And 5 years ago, we had Winter Storm Uri. 33% of our grid was unreliable, weather-dependent, variable generation, dependent on a Chinese supply chain. 33%. Passed a lot of laws to make sure that some of that equipment stays online when we really need it. Push out maintenance, this older equipment. Today, 5 years later, over half of our reliable generation is over 30 years old in the state of Texas. And we've added over 50 gigawatts of new installed capacity. 50 gigawatts. It's massive. 53 of it, unreliable, weather-dependent, Chinese-dependent, wind, solar, and batteries. 53 gigawatts of wind, solar, and batteries. We've added 3 gigawatts of natural gas. We've actually lost 1/3 of a gigawatt of coal. So 53 gigawatts. And I like to say, okay, a gigawatt of electricity generation, capital expenditure costs, about $1 billion. Whether it's batteries, wind, solar, natural gas, coal, about $1 billion. And we've spent $53 billion on crap that doesn't work when the ratepayers and the consumers need it most in Texas, and they're going to be the ones that are absorbing the cost. We could have spent $10 to $12 billion on natural gas, and that's all that ratepayers would have had to absorb, and our rates would have gone down in Texas. But over the last 5 years, they're up 28%. This is, I think, the biggest battle that our country faces is we need market reform that rewards reliability, not variability, not decarbonization. Again, I live a high carbon lifestyle. I think the rest of the world should too. You might be able to see it. I've got a bumper sticker on here that says carbon is life. Carbon is life. Guess what decarbonization is? Yeah, We know that. But I'm a positive messaging guy, so I like to think about things on the positive side and let people know this really does engage in some conversations. I've got them on t-shirts and hats. It really does engage people in conversation, and I love to do that. I love to explain to them that we're carbon-based life forms, and guess what? Decarbonization wants to get rid of us, and I'm not for that. So we've got a lot of stuff going on with data centers right now. I don't know if you've seen the news, but I believe it was last night, a city councilman in Indianapolis had his home shot up, 13 bullets fired through his front door, and a note left under his doormat that said, no data centers. Guess who's funding this movement against data centers? Indivisible, China. Indivisible got $7 million from Hans-Georg Wyss, a Swiss billionaire who funds the climate movement. So it's a climate cartel. The climate cult is also fighting data centers, because guess what you need to power data centers? I'm not saying there's not any concerns about data centers. Believe me, I live in an area that is completely dependent on groundwater, and there are some concerns about the groundwater that are certainly valid. I think data centers can have a closed loop system. That's for another story, but it's the same people that have been fighting and forcing intermittent, weather-dependent, unreliable electric generation on our grids are now fighting data centers that so desperately need this generation. And a lot of those data centers are going to, there's a model policy out there called bring your own power or consumer regulated electric utilities that's being pushed at states. It allows people to build on-site generation free of the grid, which I'm a supporter of. You don't have all the regulations of your utility commissions or FERC. You can just put this on-site generation. But one thing I would like for our state leaders to do is to hold these tech companies accountable, because the last thing I want them to do is to build their own on-site generation and then go buy renewable energy credits. Because they're going to buy renewable energy credits, which is going to force the build out of more renewable electricity that you and I are going to pay for. Every single gigawatt of renewable energy, and I say renewable loosely, it's so-called renewable energy, is under contract for power purchase agreements. Every single gigawatt of renewable energy in Texas. So a data center puts natural gas on site, they buy renewable energy credits. You and I are the ones that are stuck paying the bill with the higher energy rates and less reliable electricity. I think that's some of the biggest, that is the biggest battle, in my opinion, when it comes to grid reliability and stopping deindustrialization from happening in this country. We don't want to go the way of Germany. I mean, come on, why would we want to adopt German energy policy? They gave us daylight saving time, for crying out loud. I mean, that's over 100 years old. Seriously? We should have learned then, but we didn't. Oh, and then we see this ESG, what I refer to as everyone's suffering guaranteed, is still happening. It is still being pushed. I had the opportunity in 2020 to write a piece of legislation that would become law in Texas in 2021 that says if you boycott fossil fuels, you can no longer do business with the state of Texas. That model policy was adopted in Oklahoma, Kentucky, Tennessee, and West Virginia before BlackRock started spending millions of dollars on lobbyists and government affairs consultants. And I'm talking millions of dollars to stop our efforts. They had a little small victory today. The Supreme Court of Oklahoma overruled the law. They're saying it shouldn't even been brought to their court. Literally, the plaintiff died before the actual case could finish. And we have a setback in Texas. The law was put on hold by a court. It'll be appealed. I believe we're going to win on the merits because we have a good written piece of policy. It might have had something to do with that. But I think we're going to win there. But the biggest victory that we've seen in Texas is a judge ruled against BlackRock, who sought to have a case thrown out by our Attorney General, Ken Paxton. He's suing BlackRock, Vanguard, and State Street, the big three financial institutions, the woke climate cartel. And he's suing them and saying that they invested in coal companies in order to get those companies to produce and utilize less coal. And so BlackRock petitioned to the court to have the case thrown out. And the judge said, no, we are going to move forward with this case. And the quote from the judge in the ruling said, "It is plausible that defendants did what they publicly said they were going to do. Use their stock to decrease the output of coal." I mean, that's beautiful. And that's why it was so important for me when I wrote this policy. And I had these great debates with our lieutenant governor and his staff. And they're like, hey, lieutenant governor doesn't like that you use fossil fuels in the bill. He wants it to say natural gas, oil and natural gas. And I said, no, it really needs to say fossil fuels. And they said, no, he's insistent that he's calling this oil and natural gas Investment Protection Act. And I said, he really should call it the Pension Protection Act. It's better messaging. But and then I finally said, and I know this is being recorded and live streamed, so I may be without a job in a few hours. But I said, no, it needs to say fossil fuels because that's defined in statute. And they said, okay. And oil and gas is also defined in statute, but it didn't help me with my narrative or my admission, but it's the coal piece of that bill because I knew those companies had direct motives to deny and ban the use of coal. They're investing in oil and gas, but they were decreasing their investment in some cases in coal companies, forcing insurance companies to do the same, forcing utilities to early retire reliable coal generation so they could get virtue signaling credits to put up wind, which is just absolutely appalling. But that battle continues. And unfortunately, our former comptroller, who's now the chancellor of the Texas A&M University system, 2 days before he left his job as our state treasurer, our comptroller in Texas, he took BlackRock off of the boycott list. We had divested nearly $9 billion from pensions from our public education, or permanent school fund, which funds education. Divested nearly $9 billion from them because they were using those funds contrary to the fiduciary duty. And he thought to take them off the boycott list. Well, just months later, they start voting proxies. The proxy season voting comes up, and we publish a report with Consumers Research. Will Hild and I published this report showing BlackRock is continuing to discriminate against oil, gas, coal, and cattle. They're voting for shares at companies like Cracker Barrel. You might be surprised to know that, yes, BlackRock owns a lot of percentage of shares of Cracker Barrel. They kind of went through some branding issues earlier this year, late last year. It didn't bode too well for their bottom line. That's what happens when you go woke, you go broke. But they were telling Cracker Barrel they need to report their Scope 3 emissions and their plans for what they're going to do to reduce Scope 3 emissions. Scope 3 is something that the Biden administration, Security and Exchange Council, said it was impossible to calculate. And they removed guidance on reporting Scope 3 emissions. But BlackRock and other financial institutions continue to pressure companies to report Scope 1, 2, and 3 greenhouse gas emissions. Just absolutely mind-boggling, but they continue to do that. Well, in that particular lawsuit that is moving forward on the coal side, Vanguard recently settled. I think it's probably one of the first instances in years they're actually using fiduciary duty as a model. It was cheaper to pay the state of Texas $29 million than it was to continue to pay lawyers to fight the case. So they did a quick cost-benefit analysis, threw out an offer, Texas accepted it. Now they're going to open up their books, and the discovery is going to be phenomenal because they're going to be able to show how they were coordinating with other financial institutions to dry up access to capital to energy producers. So I think we're going to continue to see some great things on there. Another major battle that we're seeing is in the courts, this lawfare. I mentioned Greenpeace, that's a good victory. But what we're seeing is groups like the Environmental Law Institute here in Washington, D.C., since 2018, they've had this thing called the Climate Judiciary Project, where they have had over 55 junkets around the country welcoming judges to come in and go to these nice resorts and sit in on Climate Judiciary Project training seminars where they teach judges about highly debatable climate science, things that have been completely debunked by leftist organizations. They use this Carbon Majors project that some of you might be familiar with. But Snopes, a left-leaning fact-check organization, has come out and said this is false information. You can't attribute carbon emissions from a company 100 years ago to storms that they're having today, but yet they're trying to do this. The Chief Justice of the Supreme Court of Hawaii has embraced the Environmental Law Institute and their Climate Judiciary Project, and he's refusing to recuse himself from their climate nuisance lawsuit that's suing energy companies in Hawaii. Interestingly enough, there's one refinery in Hawaii. Guess who's not being sued by the state of Hawaii for causing climate change? Guess who gives a lot of money to Democrats? That refinery, and their owners do. They give money to Democrats so they can buy themselves out of climate nuisance lawsuits that the state of California is hoping to reach millions of dollars from. Now, a huge win, just last week, 2 weeks ago in Maryland, their Supreme Court, I know it's called like the appellate court, but I refer to it as the Supreme Court in Maryland, threw out 3 different climate nuisance lawsuits cases from 3 different cities in the state of Maryland. The council that was representing those municipalities is called Scher Edling out of San Francisco. They're like the leading climate nuisance law firm in the country that likes to sue energy companies. Well, they have a professor from Columbia who is of counsel of Scher Edling, advises clients. He's also helped write the Federal Judicial Center's 4th edition science training manual that was published on December 31st of 2025. I don't know what you were doing on New Year's Eve 2025. You were probably not publishing some over 2,000 page important training manual for judges. You'd probably wait till a better business day so you could get some attention by, hey, we've updated our science training manual for judges. But they do it in the dark of night on New Year's Eve. Then the attorneys, or mostly Republican attorneys general, got together. They sent a letter in to the Federal Judicial Center and said, hey, there's this highly debatable climate science chapter that references people and without citation, references people that are of counsel of firms that are suing energy companies. Kind of a conflict that's not disclosed. Naomi Oreskes is mentioned in this climate science chapter. I mean, it is just riddled with climate alarmists, people that look to profit from these lawsuits. And yet, none of that is mentioned in the none of that is disclosed. So the Federal Judicial Center says we're going to omit the climate science chapter, not rescind it, but omit it. Well, what's still in there? Guess who's still in there? Michael Mann. Michael Mann is still in this 4th edition of science. It's absolutely appalling that you have someone like Michael Mann who has been reprimanded by a judge for providing false information to juries. I think they call that lying. This guy, Michael Mann, is now responsible for training our federal judges. And the national academies, I mentioned I'm kind of a messaging guy. I've taken a lot of training seminars on how to communicate effectively, things to avoid. I love the things to avoid. Some of you may have remembered Christine O'Donnell when she ran for Senate. And I remember this, and people kept saying she was a witch. And then what did she do? She gets up on TV with a black background, which created this blue aura around her silhouette. She had a pearl necklace on, and the first thing she says is, I'm not a witch. Oh, you could have fooled me. Are you sure? I mean, I'll come on, the blue aura. Like that, you just don't say what you aren't. You say what you are. You avoid the negative at all costs. And so what does the National Academies of Sciences come out with in the Wall Street Journal? There's no judicial climate scandal. And I'm like, thank you for saying the negative. There's totally a judicial climate scandal. They said it. The National Academies of Science isn't biased. I mean, these are their words. Like, come on, you don't have an intern that like can check your communication techniques. But they went in there, they completely denied everything, and they repeated the negative in both of the headlines. And so me as a communication and policy geek, I'm like just cheering. I'm like, I love these headlines. I am using these headlines more than any. And so now I want to pivot a little bit to some of our bigger challenges. Let's talk a little bit about media, because I love media and I love the headlines. I know Steve does a great job of taking images of news stories. And so some of these, if you follow him at Junk Science on X, you may have seen these before, but I use a lot of these in my presentation. And this is some good headlines that are actually real headlines. And some of them miss some words. Food prices in Europe increased by 50% due to climate crisis. They always leave the word policy out, like, oh, it's climate crisis policy. This is from last year in Europe. Keep in mind, a few years ago, I believe it was the Buckeye Institute reported that over 70% of fertilizer manufacturers in Europe were offline because they can't get access to feedstock. You may remember this, the video of President Trump during his first administration at the UN saying, Germany will become totally dependent on Russian natural gas if they don't change their ways. And then they show the picture of the Germans. And I love it because I was like, man, if Germany could be powered by smog, they would have an unlimited supply. I mean, there's your renewable energy right there. It will never end. They just have this beautiful light over Germany, maybe power their manufacturing. But it's this climate crisis policies that are put in place that are driving up the cost. Climate change is stressing Italy's cows. I mean, I found this one before I gave a presentation to some ranchers in New Mexico a couple of weeks ago, and it's like, pro tip, don't give your cows Bill Gates approved feed. Like, they won't be so stressed. They'll actually be happy. I mean, that stuff is really causing health issues within cattle in Europe, European countries that are trying to reduce their methane emissions in cows. They're giving them Bill Gates approved feed. It's amazing. And there's another headline, Microsoft wants your poop to lower emissions. I showed this to some ranchers and said, you may have another commodity you can market. I know you guys are getting crushed right now because beef prices are down for the people that are actually producing it, but not for those that are packing it. And so I was like, gosh, you guys must be excited. You've got a new commodity to sell. I mean, Microsoft's going to come in and buy your poop. But then how penguin poop can mitigate climate change. Like, what's cheaper, penguin poop or cattle poop? I don't know. But then the headlines warn that Antarctic penguins may turn on each other because of climate change. They want to get into the market. They're going to, nope, it's going to be our poop and our climate, our penguin tribe that we're selling, not yours. There's some infighting going on. There's probably a little penguin mafia happening, staking their grounds. In the USA Today, groundbreaking study finds a natural way to fight climate change. Beavers. Man. All this global warming, the penguins are going to be moving in on the beaver territory and they're going to be taking each other out. The same author just published this one. Dung beetles have a tough life. Climate change is making it worse. I get the dung beetle was quoted as saying, I literally push shit uphill all day. Why some scientists think extreme heat could be the reason people keep disappearing in Greece. I don't know if you have any summer travel plans, but I wouldn't go to Greece. Like, poof, you're just gone. There's a portal there. Apparently, you walk in some hidden door between a subway and it says, you know, extreme heat. You walk in there and you're gone. I mean, that's just some Harry Potter stuff happening in Greece. And then on March 5th, the Washington Post, the newly revamped Washington Post, maybe not so revamped. And you talk about, it's 2016, the Washington Post had 5 reporters on climate. By 2020, they had 30. And they're revamping, they're back down to 5. So I want to thank the Washington Post for showing us what net zero really looks like. Congratulations, you've achieved it, well done. I'm sure there's 25 families that aren't too happy. But they published on March 5th, it's been so cold that cherry blossom peak may push to latest date in years. 3 weeks later, to the date, DC cherry blossoms to burst into peak bloom earlier than normal yet again. The 7th straight early bloom fits a long-term trend driven by human-caused climate change. Some of y'all have been doing this a little longer than I thought we measured climate in decades. I didn't know it was weeks, but the Washington Post, 3 weeks. It's amazing. I thought, anyways, they are getting a little bit better with some of their editorials they're allowing to be published. And then lastly, I want to point out some news that we just announced yesterday at the American Energy Institute. We're a free market trade organization. I mentioned we represent energy companies that push back on ESG and DEI, that truly support free markets, that are actually working to advance the human condition through lower cost of energy for people around the world. But we just filed a petition with the EPA on low carbon fuel standards. The Ninth Circuit Court has ruled that California is the only state that has authority under the Clean Air Act to have low carbon fuel standards, which is terrible for Californians, but other states like New Mexico, Oregon, and Washington have implemented them. We just filed a petition with Lee Zeldin yesterday to reverse that. We could literally see overnight fuel savings in Washington state of 20 cents per gallon. In Oregon at 15 cents per gallon, and in New Mexico anywhere between 10 cents per gallon by getting rid of the low carbon fuel standards in those states so that those people can actually live a high carbon lifestyle and save money while they're doing it. I encourage you to do that. Thank you all so much. I appreciate it.
Does anybody have any questions? Otherwise, I will kick it off. All right, Nate. We're gonna get your microphone and let's talk real loud.
I'll talk loud.
All right.
Okay. The microphone, the live stream can hear you.
Oh.
I got a mic for you.
And now I won't speak so loud. The endangerment finding is in the courts. Courts are concerned about legal history. We argue how does the law apply to the environmental engagement finding. So my question is this. The issue has nothing to do with the law. The issue is totally scientific. Is carbon dioxide harmful? Is it a pollutant? Does it endanger? That's the issue. But now we've got the legal cases discussing what's the law. Now, how do we get the actual scientific information to be the consideration of what they're deciding rather than past law, since past law has nothing to do with the issue?
Okay, so we're there. Okay, we have these groups that have filed to be parties in the litigation, like the CO2 Coalition. And I can assure you that the CO2 Coalition is going to be talking about the science. And the reason the science will be important is because, you know, the way conservatives and Republicans typically argue environmental public health cases, you know, they will be arguing some procedural error that the agency made. Okay, whereas the environmental groups will say, but the world is going to end. And so you have the judges making this decision. Well, they did violate the law. This I was not dotted, this T was not crossed. On the other hand, the world's going to end. So what are they going to decide? Well, they're going to err on the side of the world ending, right? But the strategy here by being an intervener, like CO2 Coalition, is to make sure the science gets presented, to make sure that, especially at the Supreme Court level, the justices have this level of comfort that the world is not going to end if EPA does not regulate greenhouse gases. Now, that's not an ultimate determination of the science. We're never going to get there. We can't agree on anything, right? But what we can do is give the justices a level of comfort that they ought to consider the law, because the science is, you know, they don't. We're covered. The world is not going to end. How's that? Okay, there you go.
Nate in the far back.
This is a question for anyone, probably Jason or Steve. I recently read that the plastics industry received some letters from some AGs about signing on to a plastics pact that could violate antitrust. So do you know where that's at status-wise?
I don't, but that
What Plastics Act?
A pact that they're basically violating antitrust laws. The plastic companies are
By doing what?
By signing this pact. Yeah.
What does the pact do?
Yeah, I guess the pact limits the amount of plastics they can produce.
Is it a treaty?
Oh,
is it a treaty? Is it an international treaty?
No, it's all domestic, and a lot of the largest producers, including food packaging.
And so it's antitrust because the plastics industry has.
It's similar. I'm semi-familiar.
I mean, you know, then there should be no trade associations anymore, because that's what trade associations do. They represent.
It's akin to the net zero.
Yeah.
It's akin to the net zero agreements.
Okay, well,
coalitions.
The Trump administration is not for that as of now, because I think there's also an international effort going on they oppose. But you have these Maha people, okay, and they're going to make us think. I'm telling you.
Right here.
This is for Jason. You talked about energy grid, and I put solar onto my house 5 years ago. And one of the things I found in that experiment, it worked great for me, but when there were some fires in California, there's particulate matter in the air. And I had 1 day with zero production and 5 days with like 5% of my normal production. But when I see levelized costs of solar and wind, it doesn't take into account the fact that you got to have backup, more than just the backup for the evening when the sun's not shining. Is there any area that's published that has real levelized costs of the various forms of energy?
Yeah, I think one of our biggest efforts that we're undertaking now is to get rid of any use of the levelized cost of energy, because it's not an accurate, a total assessment of the real cost. There's been some other people out there that Isaac Orr and the Always On Energy Research team have done on true cost of electricity. And that's why I use capital expenditure cost. I mean, it's about $1 billion a gigawatt. I know have people in the natural gas, they say, no, we can do it for 600 million, not a billion. Great. Well, then this makes my numbers even more conservative and a better story. But there are some groups out there that do really true capture the cost of electric generation and energy. But we've got to get rid of levelized cost of the LCOE. We have to get rid of it and make sure there's no use of it with any level of government whatsoever.
All the media will say solar and wind are lowest cost energy.
I heard our ERCOT manager last week at a Senate hearing tell people that like one day there's 70% of our electricity is coming from wind and solar. And he goes, and that's why Texans are seeing lower electricity costs. And I'm like, paying 28% more in 5 years, I don't know how Texans are seeing lower electricity costs. But they don't show the true cost of really, or that reliability figure. And this is something that I want to publish more often, is during peak demand times, what's the most expensive form of electricity on the grid producing? And it's rarely ever anything. And that's what people need to understand. We need to have cost benefit analysis. You were speaking of education earlier, and I did some work on improving education standards in the state of Texas, and it was for students to consider cost benefit analysis in science classes in middle school and high school when they're choosing different energy systems. And that was the one thing the Sierra Club fought us on. They did not want cost benefit analysis being introduced into kids. They don't want them thinking critically.
Just to follow up on that, tomorrow, same bat time, same bat channel, 4 to 6 tomorrow, there's going to be a great panel that spends 2 hours talking about affordable, reliable, and clean energy. And fully 1/3 of that conversation is going to focus on getting a true full system cost of electricity into state statute. You saw Louisiana start to do it last year. Oklahoma, Kentucky, Ohio, New Hampshire, all saw legislation introduced this year that mandated on their PSC how to calculate a full system cost of electricity. And in some cases, and this is my personal favorite, to ensure that they captured a true cost, was they did a 5-year look back and from any point in the future, a 5-year look back, saying you cannot consider government subsidies into your cost of electricity so that you actually do capture that. So be here tomorrow, 4 to 6, we're going to talk about that.
The LCOE is pretty useless. There's something called the FSCOE, the full system cost of energy. If you Google full system cost of energy, you'll find some analyses that actually do include the kind of things that you're talking about.
So look forward to seeing tomorrow, 4 to 6. Right here.
Sorry. I wanted to ask of Angela, the challenge of educating the students. It seems like we have some people on our side who may not even be helping your cause, saying, yes, there is man-made global warming, but we can deal with it. Or yes, there's man-made global warming, but a warming world is a good thing. And how's that affecting what you're trying to do? And I appreciate the heck what you're trying to do.
Well, as far as the warming, we just say that there's really good news that where there is slight warming, CO2 and temperature are not correlated. We can prove that. And we also think that it's just very good news for students to see the data. The problem that we have is getting them the data, because the teachers refuse to allow it. And so this is really a grassroots effort where we really need to make sure that parents know, so that they're going to their school board meetings and saying, I will not tolerate this. I want my child to learn real science. So we need more of a movement. But when we go to these conferences, even the homeschool families, they'll see our banner that says, good news, there's no climate crisis. And they stop and they say, I've heard this, I have kind of a gut feeling about this, but I've not seen the data that shows us. And I say, you're in the right place. And they leave so relieved. And we went to the America Fest convention, TPUSA convention in Phoenix, and we had the opportunity to talk to so many college students that were very intrigued by our signage. And they stopped and they said, and they had questions. I had these college students that would talk to me for half an hour at a time. They would just say, wait a minute. I had this one student who, he was an environmental science major at Auburn. And he said, but CO2 is the main driver of temperature. And I said, no, that's the sun. and he said, oh my goodness. And he literally like had this light bulb moment. And he said, oh my goodness. What we're learning is that all the warmth and the devastating heat that's going to come to the world is from CO2. So I stacked him up with literature, and that happened, not the same conversation, but about 10 conversations. And that's why that percentage, 42% of Republicans, young Republicans, believe in a human-caused, man-caused
terrible
climate change. And that's a result of the indoctrination in the schools.
All right, we have time for a couple more questions. Gentleman in blue.
Yeah, it's John Hafner. I'm a retired educator. I have a question for Angela. Do you think that the dumbing down of science education is deliberate?
I personally do. I think when I told earlier that next generation science standards were introduced in 2013, they specifically removed the traditional scientific method. Why did they do that? It reduced critical thinking, and now students are taught what to think and not how to think. And that's problematic. Critical thinking is no longer the main objective of science education in America.
All right, I'm going to actually exercise moderator privilege. We got only a couple minutes left. So I'm just going to ask one question of the panelists. Have 1 minute to answer. What's a win look like on what you presented? Have 1 minute.
A win on what I presented would be for the other climate modelers to start involving constructive law in the climate models that they're making, and for scientists in general to pay more attention to the constructive law.
All right, very good. Steve.
Well, two things. We need to overturn Massachusetts versus EPA. That is job one. And the second one, a congressman called me up early on in the Trump administration and said, Steve, somebody told me to think about disbanding EPA and sending its pieces to different parts. So where would we do that? So that would be disbanding EPA. Be a great start.
Perfect.
So if Zeldin gets nominated to be AG, then Steve Milloy could be the last EPA administrator. That'd be awesome. Mark me is down for that. No, I think the biggest victory would be market reform that rewards reliability and stops what I believe is the greatest misallocation of resources. They call it investment. When I was in the legislature, I was sold that this is economic development. This is investment. We're going to spend billions of dollars and we're going to hire a bunch of people. It turns out they weren't hiring anybody to put up wind and solar. I mean, they were short-term temporary construction jobs that were supposed to create 10 full-time jobs for decades. And you come out and find over 80% of the projects in Texas got waivers from their job requirements. They were creating one job in rural areas, but yet we've spent billions of dollars that ratepayers are now on the hook for decades. So I think it's the greatest misallocation of resources. As Chris Wright says, we've been putting these parasites on the grid. We need a market that rewards reliability.
Great. Angela.
Reinstating the traditional scientific method in public schools. And the good news is that we can do that because, as I mentioned earlier, John Droz did that in North Carolina. He went to them and said, Did you know you're not, to a congressman, did you know you're not teaching the scientific method, the traditional scientific method in public schools? And they didn't even know, because this went in very surreptitiously. But we can do that, but we have to fight to do that.
All right. So I'm giving you 2 minutes of your life back, which most think tanks don't do. So dinner is at 6:30 upstairs, downstairs in the ballroom. So please, big, huge round of applause for the panelists, for Nate, the AV team. Thank you.